Nothing on this show is authorized by the Food and Drug Administration, and nothing said here is intended to treat, cure, prevent, or diagnose any disease. Contact your physician before starting a diet or exercise regimen, including supplementation. This is not medical advice and is for entertainment purposes only.
All right. I'm gonna wait for the chorus.
You want to?
Yeah. Do we have another verse before the chorus? Yeah.
Coming up.
They go into it quick. Go your own way. Ladies and gentlemen, this is the Supp Works podcast, and we are coming to you tonight with two of the greats from American River Nutrition, Dan DiMarino and Dr. Barrie Tan. Welcome to the show.
Thank you.
Good to be here.
And good to be here.
So naturally, this is an exciting one for me because we get to nerd out, and we've gotten to talk about marketing and stuff. How many episodes in are we?
23.
23 episodes, and we just started the show this year. And this is our first episode where we have a subject matter expert on a particular ingredient. So there's so much I want to get into, but there's really two meaty ingredients that we're going to talk about tonight. But they come from the same plant. It comes from the Annatto plant, Pixa aurelia. But first, I want to get into talking about some of your backstory, getting into probably I would say going into your undergrad. What were you thinking your life was going to be?
Well, whatever I was thinking was not what it ended up now. So I think at the time I was fascinated with how molecules or chemicals would interact with the human body so that it would help us to have improved health. But even though I thought that, I don't know how to get there. And then I was studying basic chemistry. At the time, I was hot in understanding of polysaccharide because, sugars like that. And it was doing that. It was in the 1970s. And in the 80s, people were interested in proteins. And those things change like that, depending on the extent of understanding. And then when it came to the 90s and 2000, I went back to understand why people get Nobel Prizes in the vitamin. See, it's very old school now, but I wanted to do that because it would help me. And I increasingly was interested in lipid-soluble ingredient. So therefore, lipid-soluble vitamins, meaning vitamin A, D, E, K, those ones. And associated things that not survive to become vitamins, but nonetheless important lipid nutrients like CoQ10,
Which
like that.
Should be an honorary vitamin in itself.
Right. So those things is always in the back of my mind, and that's in the back of my mind. And in the front, and then they are led by different things depending on what I discovered in the plant. So I'm sure we'll talk more about that.
So, but you were into chemistry and biochemistry and going through this, and where did your fascination with the plant world really start to come into focus? What you were telling me earlier, it had to do with the transduction of light, right? With the pigments in the retina.
Oh, even before then, that came about when I went to University of Massachusetts teaching. I went there. I did my postdoc at Auburn University, Alabama. It's more a football country than anything else. But the professor was very interested in toxic material, what causes cancer, like that. So it was a little diversion, but nonetheless, toxicology is a flip side of biochemistry. It's just how things go bad
stuff, yeah.
rather than how things go good. So it did lead me to that, but I was interested in cancer causing. And he was looking for chemicals that causes cancer, and it was EPA funding. So when I got that learning, and then I started my career at UMass, there were no anything that caused toxicity. Then the beginning, except for some things in acid rain, but then there was a big oil spill, PCB spill in the Buzzards Bay, in like that. So then you can see it's furthest away from nutrition. So I started to do that, how PCB causes cancer, all these things. I was making publication, this and that. That was when one bright day, it really was when that changed. It's not a spark, a change. Then I said, the only good news I bear would be bad news. I think I'm not saying this negatively, If things are not good, somebody have to talk about it, But then the only good news I bear is bad news, and say I need something more positive. That was when I thought I wanted to go in the area of nutrition. That's probably in early 1980s. That was when I thought palm oil. Most people think of palm oil saturated fat no good, but
some people look at palm oil in a positive way, even though it is saturated fat.
Yes, like that. And for me, it was not that piece that got me in. I was born and raised in the country Malaysia. And 80% of all the palm oil comes from Malaysia and the neighboring country, Indonesia.
Borneo,
Indonesia like that. And Borneo is included. So I got a grant from them to say that we produce so much palm oil and they are vitamin E, they kind of know that it's vitamin E. And we want to know what is the vitamin E that make the palm oil very stable. They use it for making cookie, deep frying, that work. So
it's a preservative, right? Or it's an antioxidant in foods.
And then, so when I got a small grant to do this is when I was at UMass. And they say, oh, you expect that it's vitamin E? We just want to know how much vitamin E it is. And when I look, then I say, hey, it is vitamin E, but when I run a chromatogram, and I got 4 peaks. That means, and then I identify one of them is vitamin E, alpha tocopherol, but the other 3 are not. You cannot have the same vitamin E with showing up in 4 different places. You can't do that, Then they no, it is. Then I decided that my curiosity got the better of me. It's 1983, I think, at that time. Then I found out, wait a minute, this vitamin E have an unsaturated tail. And he said it is very related to tocopherol, but it's not tocopherol. So that was the first interest that dragged me into nutrition. But at the time, 1983, nobody know other than, this is kind of like a version. So I delved deep into the literature for whatever. Now they have 20 times more things published on vitamin E than then. But then I did read. And what I read aroused my curiosity even more.
Did anyone have any idea about this potential structure back when you were looking into this?
Yes. Then when I went in, this tocotrienol was discovered by University of Bristol professor and then by USDA of all places. But then
what year was that?
That was 20 years earlier, 1960s. But
okay.
Then when they discovered it, and then they say the structure, but then the nomenclature scientists, which mean people who give names to chemical.
There's a big IUPAC name
like that.
Nobody
so
understood.
Rather than saying that they are tocotrienol, when they are, instead they call it the normal tocopherol. It's called alpha, beta, delta, and gamma tocopherol. So you would think that they will call this alpha, beta, delta, gamma tocotrienol. Instead, I know people think this is funny, but you look at the literature, they will find out it will be nu, zeta, phi, tocopherol. So those tocopherol are actually tocotrienol. So it took the Merck index and publication 20, 30 years after before they stopped doing it. They are not nu, zeta, and phi tocopherol. They are tocotrienol. So therefore, tocotrienol is almost a vitamin E stillborn. So I persisted on it and studied and then study the area of cholesterol reduction, lipid reduction.
All right, let me slow you down for just a second.
Okay.
Let's go through some nomenclature real quick in case people at home are not keeping up.
Okay.
Saturation. Whether it's saturated fats or unsaturated fats, it's the comparison of the saturated fat that can give you heart disease or the unsaturated fats like omega-3s that have more double bonds. And we'll get into that when we talk about GG a bit more about double bonds and how those are kind of named. But basically, like, they both have some sort of value in the body. One in large amounts could be deleterious. One in the large amounts on this other side can actually be really helpful. And I think that was kind of interesting how you were talking about how you were studying toxicology and the PCB spills and like only having like this bad news kind of thing. And I think it's funny that our whole medical industry has like this fixation of here's all this realm of disease from death to healthy. and that's all that exists. But nobody's really like looking at the use of like vitamins and supplements to be like, hey, maybe there's this whole other side of the spectrum that might exist like beyond healthy, where you could actually do like productively good things for your body that give you advantages over just being healthy. And like just consuming lots of antioxidants would be like a really good example of that, where you have like the ability to reduce reactive oxygen species at a better rate than like just say a normal person. But I totally resonate with like the ability to go and tell someone good news. It's like, I might have this kind of a disease state. Well, if you just did these positive things over here, you could help pull yourself back to the middle toward healthy. So saturation. And all right, so the other thing I wanted to ask you about, you kept throwing all these Greek letters at us. If you could explain the nomenclature, because we got the structures pulled up right here. Eduardo, if you could screen capture this thing, we'll do picture in picture. Can you explain what makes an alpha, a beta, and a gamma, and a delta differently based on what we're seeing here?
What's up, everyone? TK here with Nutramedia, and today I want to talk about the sponsor, which is us, Nutramedia. As you know, Supp Works is filmed here at our Nutramedia studios in Willis, Texas, and we are a full turnkey design studio. Really what that means is we help brands create their identity systems, their logo, their fonts, their colors, their textures, their patterns, and then apply that to the greater spectrum of their brand. So like their packaging, labels, whether it's bags, boxes, whatever your packaging is, we help design that. We design it for print, and then we take those assets and those ideologies and then build it out so it's scalable for your marketing. That means your merchandising, your promotional needs, your booths, things like that. We're a full turnkey graphic design studio. We have 7 in-house designers, including myself, and we also can do some auxiliary media like editing videos and helping with websites, helping do things like podcasts. So anything in the world of CPG, supplements, packaging design, media, we are your go-to agency for that. You can always contact me directly, tk@nutramedia.co. You can also contact Blair. She helps with our sales, blair@nutramedia.co. And if you're looking to get started on a project, just know that we're very flexible with pricing. We have an hourly buy-in in which we ask people to sort of buy into a retainer. And then once that retainer is met, we're just hourly after that on a month-to-month basis. We're very flexible with most brands. You know, don't come to me with like a one-off thing. We like to work on larger projects that have continuation over a course of time. We have some clients that we've been working with for well over 3 years, and they ask us to do things for them every single day. And that's really where our bread and butter is being an attachment to your marketing to help you create assets that are high quality at rapid speed so that you can scale your business. That's what Nutramedia is. So if you guys are interested, go to nutramedia.co, no M, nutramedia.co. You can fill out a form, or you can email us directly. You can also just DM us, or you can also find us on LinkedIn.
Okay. I'll answer the first part first. Why the saturation and unsaturation? The saturated vitamin E is called tocopherol. The unsaturated one is called tocotrienol. Forget the ring part on the left. When you talk about saturation, unsaturation, it's on the tail part on the right. If you look at the tocopherol tail, they're saturated. You see there's no double bond. So they're just meaning no double bond, meaning that they just have hydrogen and carbon with no double bond that bridge it. Double bond that bridge it will make it tighter and then a little bit shorter. So if you look at the tocotrienol.
And less hydrogen.
And less hydrogen. And then for tocotrienol, you can see there's 3 double bond, and hence the word tri means 3. Tri-ene means 3 double bond. All means alcohol that refer to the right side. So therefore, the tail of a tocotrienol is slightly shorter. I'll explain the nuance of the slightly shorter in a minute. So the second question you asked is...
Words in chemistry mean a lot because it details what's going on in the structure of the molecule itself.
Yes. But if you look at the two structures, they're very similar, hence they're part of the family of vitamin E. You ask, why are they called alpha, beta, delta, gamma? That has to do with the ring part. If you look at the ring on the left side, you can see the first ring. We call that aromatic ring. Probably we don't need to go deeper into that. Aromatic meaning that they have the best shot in being an antioxidant, and the plant conceived it. The human body make this kind of thing very rarely. And unless you are interested in it, people have aromatase inhibitor for women who have breast cancer, this and that. But it's very uncommon for a aromatic ring made by the mammal. But aromatic ring are made by
And that applies to a lot of things, like most essential fatty or not essential fatty acids, but essential amino acids. Your tyrosines, your tryptophans, your phenylalanine, stuff like that. Those have aromatic, and histidine. Those have aromatic rings that you're never going to find inside the body. The body it's not in their wheelhouse to make aromatics.
But in the plant, it's just all the time, like think of some famous one, EGCG, resveratrol, quercetin, they all have aromatic ring, but that also have very different thing from this. And I mean, we're going so many different directions, but I wanted to
Let's keep it here.
hold on, focus in this side. So depending on how much methyl group is on that ring, if it's fully methylated, then they are alpha tocotrienol or alpha tocopherol. If it's got 2, then it's a gamma or beta. And if it's got 1 methyl group, then it's delta. And then we found out that when it had 1 methyl group, they seem to capture the free radical the best. So that's the ring part. If they got 1, so hence delta. But you notice that I said earlier, the tail of a tocotrienol is slightly shorter. Why? Because when you have double bond, when it's 1 bond holding it together, it's this. When you have 2 bonds holding it together, it's closer.
It's tighter.
When you have 3 bonds, even closer.
You said tighter,
So therefore, the whole thing will be shorter. Why is that good? I love to tell this story, and everybody love it. I made it up. And then
It's accurate though.
but it's accurate. But let me tell you, before I tell the story, how this was discovered. It was shown by Professor Lester Packer of UC Berkeley. He has since retired and passed away. He used alpha tocopherol to compare with alpha tocotrienol. So nothing in the ring changed. Then he created a lipid membrane which have fatty acid, and then he puts in alpha tocopherol and he challenged the lipid, and then you see how fast it gets oxidized. Let's say the alpha tocopherol they put in, if it didn't...
So he shot free radicals at this bubble.
Yes, and then he put in the alpha tocopherol. Let's say if it's got no alpha tocopherol, they just zap it, and then the thing will get oxidized 1x time, 1x. And then when you put in alpha tocopherol, then you'll get like 2x. So in other words, it prolonged to get oxidized. But when he put alpha tocotrienol, listen to this, he's got 50 times, so it's 100x. Then he was troubled by that. How can you have an antioxidant? He would have accepted it if he put alpha tocotrienol, if it's 4x. He's not a cynical guy.
But not 100.
But not 100. So something is the matter that you have to explain this. You cannot say 50 times more potent. There must be an explanation. He figured it out. He used this technique. It's seldom used. It's called electron spin resonance. It's very difficult to do. So that means if you think of a cell like a bean, and then the alpha tocopherol will go around like this. So when the free radical come after the fat, then the alpha tocopherol nail it. So it won't oxidize the fat.
So there's some sort of like electronegative kind of attraction going on there between the free radical and the antioxidant.
Even better, even clearer. He actually measured the rate of the spin of the alpha tocopherol. So how fast it can capture the free radical. So then,
and this is floating about in like a double-layered plasma membrane.
If you think of the layer as a cell wall.
Sure. I'm thinking of it like a liposome.
Of a liposome
Sure.
like that. Then he used alpha tocotrienol. His spin resonance said that it's spinning around the liposome 50 times faster. Bingo. He explained it. So it is not chemically that alpha tocotrienol is better. It's able, because the tail is shorter.
They swim faster in the surface of the liposome.
No, you use the word anchor. Because the tail is shorter, see the whole tail is lipid-soluble.
Right.
It will poke in, so therefore if the tocopherol tail is longer, it anchors into the water deeper. So it therefore moves slower. The tocotrienol anchors less, so it spins faster. that was it. So then the practical example is, I think of the tocopherol and tocotrienol, they capture the bad guys. So there will be the difference between a police and a state trooper. A police will be stay within the confine of the town or city, but a state trooper will go all over the state.
Yeah.
That is the function of a tocopherol and tocotrienol. So I did not say a tocopherol does not capture free radical. Its efficiency is different than that of tocotrienol. And why? Because the tail is slightly shorter. And why is that? Because there are 3 double bonds. That's it. That is the simplest way I can explain it, and it's not chemical.
So to dumb this down for like a consumer, this affects saturation.
Yes.
This affects a lot of things, and it's also referred to as like free radical quenching. So like your body makes free radicals all the time from breathing and from doing like extensive exercise and stuff. And what this does is when your body makes free radicals, like it's just like a constant attack on all your cells. And that bubble, that liposome, that cell, like he was talking about, is any cell in your body, like completely ambiguous, whether it's brain, heart, muscle, what have you, or even fat tissue. But the unique thing about this tocotrienol is it will embed into the plasma membrane of these cells, and it can just kind of sit there and chill out and wait for this to happen. And instead of it actually coming in and it's called lipid peroxidation, when a free radical comes, it damages your outer membrane of your cells. So this is it's a pretty common occurrence. Even if you go out drinking and your body produces more free radicals, like you have more lipid peroxidation of your cells. But if you have a lot of antioxidants, especially fat-soluble antioxidants like this, if I were to give it another metaphor, imagine you're planet Earth, right? And you want to protect planet Earth because
I was thinking about an orbit and a meteor orbit. That's how I was picturing it in my head.
Think about if we had like Guardian satellites and some moved kind of slow and they were there, it's just a matter of deflection. So if a meteor is coming in, this satellite is designed to hit the meteor and deflect it so we don't get hit. But then you have like the tocotrienols, which move considerably faster and they cover more territory more frequently than just like something that's just barely kind of floating there. And it's because of that shorter tail that it can cover so much more territory.
This is vitamin E we're talking about.
Yes, it's vitamin E we're talking about.
Okay.
Yeah.
Now that was another beef that I kind of had. It's like, the FDA recognizes tocopherol, but it doesn't recognize tocotrienol as a vitamin E. And I've had frustration many times where I'm making a product and I'm like, why can't I claim tocotrienol as vitamin E when it does everything that vitamin E does, and it does a better job and it does even more functions outside of it?
I think that for the scientists, all scientists have already accepted that vitamin E include tocopherol and tocotrienol, but FDA did. But the FDA have moved a small step. But I don't want to say that yet because I wanted to stay with this topic, which I feel is important. I say this many times. There are many antioxidants the plant make. If I tell you some, and people don't even dare to talk about it because it's just confusing, Resveratrol is a very good antioxidant, and it's anti-aging,
very popular product right now.
And then shortening of the prevent the shortening of the telomere like that. And berberine, I check it out also. Berberine it has a nitrogen group. So
it's an alkaloid,
It's an alkaloid like that. Weight loss, sugar control like this. But if you look at them, they also have antioxidant property. Antioxidant property have 2 things. If it is a chemical, it must have a benzene ring like you see here. But then if you look at antioxidant, people use the word so it's trite. But let me tell you about oxidation. We have 4 main groups of things in our body. I'm bringing it down as best as I could.
Okay.
You have protein, you have carbohydrate, you have fat, and then you have a 4th one, at least to the USDA. You have a nucleic acid that make all the DNA in your body. So for me, when I think of antioxidant, I think of one. And if people challenge me, fine. I think of lipid peroxidation. That's therefore the fat.
Yeah, and clinically, that's the most measured one.
Yes, that's the most measured one, and there's a reason for that. And then you can oxidize carbohydrate. We have a measurement of A1C for people that have too much circulating sugar, so the glycated hemoglobin, blah blah blah. That's A1C. So then it's a fat that's a carbohydrate. You can also oxidize protein like that, and you can also oxidize DNA. So I usually win people. I just say, by the time your nucleic acid is oxidized, you are really dead meat.
You've really oxidized
because
everything
that's
else.
right in your nucleus. That means that you already gone to this and that. You are really dead meat by that time, So let's talk about the lowest level of oxidation. You need protection.
The first line of defense.
First line, that is the Minuteman, like the Massachusetts Minutemen when the British soldiers came like that. So that would be lipid because they're the easiest to get oxidized. You just put a stick of butter outside there, or the first smell from the roadkill smell. It is not the protein, it is the fat, and also when you think about a fish that go bad, that smell. So therefore, in my mind, when I think of oxidation, I think of lipid oxidation. I don't want to hear about other things because that's the first thing that go. So now I capture the audience and I force you into that thinking. Too bad I have to say that. I force you into that. So now you say, so what are good antioxidants for lipid peroxidation? Now I have a chance to say it is not going to be berberine. It's not going to be resveratrol or EGCG or curcumin, all this wonderful stuff. And you know why? Pull out those structures sometime. They're going to have one ring here, and you're going to have one ring here, got OH group here, and OH group here, antioxidant for sure. But then they are two-headed snake or three-headed snake. So now, if you think of a membrane, it's phosphate group and fatty acid. How can you stick in a three-headed or two-headed snake in? They just don't stick in. It don't fit. So what does it fit? That antioxidant must look like a sperm. Look at the vitamin E. It looks like a sperm. You see that? Yeah. So that OH group here is sticking out with the phosphate group. And the tail is lipid-soluble, sticking right in there, you see? That's it. So which is why tocopherol and tocotrienol, they are the best antioxidant for cellular protection. So otherwise, you're going to have million people talking about every darn thing in the universe antioxidant. I just cut it. Every time I cut it. Otherwise, you say, first protect your lipid, man, because that's the first thing to go. Otherwise, then, when your protein get oxidized, like in your muscle, you can ask me later like that, even in your muscle, when people are not doing muscle properly because there's too much fat in the muscle. You're insulin resistant. It's the fat in the stupid muscle.
Because there's structurally, sometimes the free radicals are generated from within inside the cell. And in that case, there's carbohydrate and protein that can get oxidized. But then you've got external insults, things that are coming from the bloodstream or things that are coming from the sun, for example, like UV radiation. So if you think of like your cell again in like the model of the earth, you got crust, mantle, core, and the crust is that's your lipids, right?
Yeah.
That's your external shell that really protects the more valuable things that are inside. And as you make your way in, okay, you got protein and carbs that are there in the mantle.
Yeah.
A lot of proteins are kind of like structurally holding the cell up. And then you've got the DNA and stuff. That's the core, right? And like you said, if your DNA is getting oxidized, of course you're dead meat because you've already penetrated all these other layers.
All the way there,
And it's very, very like rare occurrences that we'll get into later that will have that kind of effect. But there's mitochondrially like generated free radicals that can do that stuff. And I think there are a place for like certain antioxidants that if you can get them into the cell, that they could have some value, like the resveratrols and stuff like that.
Yes.
That once you get them past the crust, which is the very hard feat to do in the first place, that, okay, they can exert their antioxidant effect, and that is helpful. But as far as like you were talking about with like lipid peroxidation, you've got, and this is so niche because it's showing that, each antioxidant has its place. And it's not to say that like one's better than the other. But they all have their roles in the strata of your cells.
On this one here, right? And then we don't have to beat the dead horse on this. There was a Austrian professor, and this is in the 1980s. It's very classic, They ask questions because they don't have molecular biology we have today. He was just highly curious, If you take of a human cell or mammalian cell, he wanted to know what are all the antioxidants in there. these are not supplemented. Your normal cells. He's
Oh,
going
like
to do that.
internally,
Yeah,
right.
and then so he extracted it from this cell wall. Then he documented it. This is really cool. This gives you huge perspective. 90% of all the antioxidant that reside in your cell wall, and we have 38 trillion cells. We have a lot of cell wall in the body, like that. 5,000 times the population of the earth. Is 90% of the antioxidant, he extracted it. They are vitamin E molecule, tocopherol and tocotrienol. Then the 10% is everything else. And most of the 10% everything else, leading the pack is CoQ10. Our body makes CoQ10, it protects it too. And then a small amount depending on your diet, maybe MK4, maybe some other antioxidant that you take that our body don't make, but it'll be tocopherol. And even, let's say, forget the other thing. Just the vitamin E, tocopherol, and tocotrienol, and the 10% CoQ10. Just think about it. The 10% CoQ10 is made by the human body. They made it to protect. The vitamin E the human body doesn't make. So can you get the idea? The body is trying to absorb all the tocotrienol and tocopherol it can because it is tailor-made antioxidant for the lipid. And the other 10%, nobody was making CoQ10 then. You know what I mean? The body makes the CoQ10 and places it there and only places 10%. So therefore, the tocotrienol is, if you were to put in a CoQ10 like that, the cell wall fatty acid, let's say C18, maybe C22 if you take fish oil, but most of it is C18.
He's talking number of carbons.
So if you were to have CoQ10, the CoQ10 head is here, they look like this. The CoQ10 tail will go like this. Like this. You see, it cannot stick through it. If it sticks through it, it's in the cytosol, then it's in the mental. It can't do that because it's water again, like that. So it's awkward. But with the...
Is that doing that without a cis bond just because it just doesn't want to be
No,
near
it's too
water?
long.
It's too long.
Long, because
it's a saturated fatty acid, so it's going to curve on its own anyway, right?
yeah, or the curve on its own go like this and like this. But the whole thing is only about 4 nanometer. But the CoQ10 tail is about 5 to 6 nanometer. Actual length is 5 to 6 nanometer. So it go all the way. It can't stick in the water, so it just curved that. It's awkward. So, I now know.
So that's the other thing about the saturated bonds. The saturated bonds have free rotation. They can turn and twist and do whatever they want to do because they're floating around in three-dimensional space. But when you have like desaturation, like in tocotrienols, they're kind of locked in place. They cannot rotate as freely and they can't twist and turn on themselves like these other fats.
Which means that for the protection of the lipids is actually better. So this is kind of like not new on. Scientists know this, that they've done so many lipid antioxidant thing, but I only don't talk about them because other people say about Dr. Tan, I know it's antioxidant, but there are hundreds and thousands of antioxidants. Then I have to explain what I explained earlier, like resveratrol. Resveratrol has about 4 OH group on 2 separate phenol group, like that, and EGCG have 5 to 6 of them. So there are many antioxidant property, but then they can't stick in the cell wall, so they only work on the top. But you mentioned a new one. What resveratrol can do is that they cell signal. They signal so they can go into the mental and then they can go into the core also. Tocotrienol have cell signaling thing, but explaining cell signaling thing to the consumer is difficult. So what I'm explaining to you is not cell signaling.
We're going to get there.
We're not talking about cell signaling. It's actually working to protect the physical lipid. Yeah. So there's lipid antioxidant potential, and approximately 25% of our body is fat, and those fat are challenged like that. When you talk about a GG thing, it had to do with 40% of our body that is skeletal muscle. So I know we talk too much on these type of things. Okay.
Dr. Tan's trying to say, eat your vegetables, eat your leafy greens.
Oh, we're not even there yet.
Eat your plants.
Okay.
Eat your plants, man.
All right, let's go back to the jungle, because when you were doing this work for the government or whatever, you're studying palm. They want to know how much vitamin E is in there, and you find these other things that look like vitamin E, but you're not sure. And you're going through the other research, and you're seeing that the USDA and someone else had found these odd ball vitamin E's that they didn't really know what to call, and then they called them the wrong names. Like, this is the same story with like finding new species. We're gonna call it this thing because it's the best we've got for right now. But 20 years down the road, they're gonna be like, oh, it's actually related to a chicken. They'll run some DNA analysis and rename it and recategorize it. But I think that's probably like a similar thing, like with your Tocotrienol naming.
Mm-hmm.
Was this before or after, like, your fascination with the retinoids and like vision and stuff? Because I kind of want to take it from Malaysia to Peru.
Oh, the Annatto fascination is after. The reason I mentioned that is because when Tocotrienol was first discovered, this is telling. It was first discovered in latex rubber.
Yeah,
and you may or may not
that.
know, latex rubber have the highest content of unsaturation. If you ever go to Malaysia, you tap a rubber, it smells. It oxidizes faster than any fat can oxidize. And would you believe it? The rubber produces specifically delta tocotrienol to protect the latex from oxidation. So suddenly, that was a bing moment for me. Aha, this molecule is able to protect. So I put it in my head somewhere that delta tocotrienol.
Could like Tocotrienol even act as like a preservative for like fish oils or for liposomes?
100%.
So this is why tocopherol is usually in liposomal formulations.
Yes, that's it. So and we did the study, by the way. Now I'm jumping on it. I had a company make soft gel for me, fish oil, and then I said, please put in rosemary extract to mask the smell.
And usually that's the same function
you like
would
that?
have.
So one have rosemary extract, and one have alpha tocopherol, and one have a tocotrienol, mixed tocopherol and tocotrienol, and then Annatto. The Annatto tocotrienol, the peroxide value is lowest. The amount, when the fat break down, they break down to small amount of water. So we measure the water is also less. And so all that to say, the tocotrienol protect the oxidation of the fat, the omega-3 fatty acid the best. So some companies do that. We have 2 or 3 companies do that. And we did the test just simplistically to add the tocotrienol to extend the shelf life of the fish oil. So if people are hearing, if you're making omega-3...
I was going to say, do you guys ever sell your tocotrienols for like that antioxidant preservative effect for other soft gel formulations, liposomals,
Yes.
etc.?
Yeah, we do.
God damn, that's a fancy liposome.
More people should be doing this. You only need to add a small amount for extending the shelf life. Particularly people who do liposome.
How much longer does it increase the shelf life?
You only need to add about 500 parts per million. It's a nothing. 1,000 parts per million is 0.1%. Okay, 1,000 parts per million is 1 parts per thousand.
You only need 5.
And then therefore 500 parts per million. So therefore it's 0.1%. So 500 parts per million is 0.05%. So it's a nothing. It doesn't even cost anything. And then it will increase the shelf life of the fish oil. So if your audience are hearing, that's a simple ad. And it barely is 1 gram of fish oil, like oval, is only require 0.5 milligram of tocotrienol. How can that be any cost like that? And that's just to do that. Nothing to do with the function of what tocotrienol can work on chronic diseases like we have done a test with. So that rubber was the thing that triggered in my mind, this delta tocotrienol is more active. But I haven't discovered
that in Malaysia at the time?
That was in Malaysia. No, because I discovered the tocotrienol in palm oil, then I started to read in the literature, then I know delta, and then I was slightly disappointed because the amount of delta tocotrienol palm oil is very small.
Sure.
Gamma is high. But
there's a lot of companies that are selling other tocotrienols from
like that.
palm.
But that put in my mind that tocotrienol is more potent and delta more, just not in the... Then I stopped on tocotrienol. That was life had ups and downs even in science.
That's what I was kind of wondering. Is like, did you just kind of put this on the shelf?
So it was palm. It was the Annatto was the last. I actually have given up on tocotrienol. Yes, you heard Dr. Tan right. I gave up because I did it on palm tocotrienol. We went all animal study works, and we went all the way to use it to do clinical study. We did 5. 2 of them worked, 3 of them didn't work. Then the odds are not good. So Professor Kurashi, the father of tocotrienol, University of Wisconsin, he said, Barrie, we got to stop this clinical study. It's taking too much time, even though I got funding.
And the results are boring.
So he figured it out. When he did the palm tocotrienol, that was the only source of tocotrienol. So we have alpha tocopherol, 20% of the total mixture, all the way to 35%. When we first did this, we thought the presence of the tocopherol was innocuous. It's just there. It's antioxidant,
it's
no
not
problem.
Special.
It's not nothing special. But then he put in a meta-analysis. When the tocopherol is 15-20%, then of the mixture, and then the other one are tocotrienol, they work to lower the cholesterol. But when it get a 20, 25, 35%, it's not working. Then they say, wait a minute, something is the matter with this. So he said, I'm going to stop all my clinical study. Can you imagine that? The guy is feeling a lot of pain. This takes long time to do, even if you get funding. And he's a researcher, right? So he published it in 1997 in Journal of Nutrition. He used pure tocotrienol, and he used different groups of animals, exactly the same amount in each group. The only change, pure tocotrienol, nothing, just pure tocotrienol. Same amount of tocotrienol, 20% alpha tocopherol. Same amount of tocotrienol, 40%. Same amount, you follow me? 60%. So as he did that, the ability to lower lipid went this way. So as the alpha tocopherol increased, the ability to lower cholesterol went this way, even though the tocotrienol is exactly the same. So now you fast forward today in cancer research, exactly the same. In metabolic syndrome and fatty liver disease, exactly the same. So initially I was preaching in vain. I just said that the alpha tocopherol is interfering with the function of tocotrienol. I got so many people challenging me on it, and I have no shame because I was not pushing anything. I didn't even discover Annatto tocotrienol yet. I just said that, and then you know how I get challenged? I said, Barrie, holistically, it is those pharmaceutical company, they make one drug, one thing, and it works. But holistically, one is good and it's a mixture. I don't necessarily disagree with it. But if you are a true holistic person, if you accept the concept of synergism, which is what they imply by that, then you cannot reject wholesale antagonism. So if they are antagonism, you got to stay it. So I said that this is not the first time. Then see, because I'm 70 years old, I've been reading literature like mad my entire life like this, I said, what have you known that does it? He said, I'll tell you one. Before there were lutein and zeaxanthin like that, there were beta carotene, because beta carotene convert to retinol like that. It's good for the eye and all this wonderful stuff. Then I said, Then lutein came into being. So people said, lutein is good for the eye filter, the blue light like that. So this professor, University of Illinois in Chicago, so she put beta carotene and she put in lutein. And you know what happened? As she increased the lutein, it inhibit the body ability to absorb beta carotene. See? So therefore, they are same material. So therefore, I was not shocked. So after that, we insisted on this. People will bluff their way into saying the palm tocotrienol. We did so many studies like that. So it's not like, so now get to the story. I gave up because I cannot reduce the alpha tocopherol, and it's not reducing. I was young, 30-year-old assistant professor. I was discouraged because I don't know what to do. I have to chemically cut the alpha tocopherol. It would be massively expensive. I can't do that. And
why couldn't you do that?
Professor Kurashi did do that. When he cut it out, so he went back to doing clinical study, but he cut it out. But it's a lot of effort to cut it out. But when he did it, he's a professor. He wanted to prove his concept is right. He did. And it worked to lower the cholesterol. Then I just said, well, I don't have a natural occurrence of a tocotrienol without tocopherol, so I'm out. So therefore, that was when I read Professor Johanna Seedon's work about this lutein and zeaxanthin that filtered the blue light. At the time, as I was studying tocotrienol, I was also studying carotenoid. I'm a carotenoid chemist as well. So I went, okay, so that I'm jilted with my first love. I can't make this tocotrienol stick. I might as well do my... And then...
So you changed lanes.
And then I changed lane. I said, oh, look, she talked about lutein and zeaxanthin. This is 1994. People not like today, everybody know about it. Oh, I know this. So I took a first flight to Peru. Look at me, man. I speak English. I'm Chinese. I can't speak a word of Spanish. So, and then a lot of this kind of thing in China. But I didn't go there. I went to South America. So I think this is fate. I went there. I did see the giant marigold like that. I was happy. I got what I went there to look for.
You were looking for the marigold.
Marigold. And then literally 30 feet away from me, this is a true story. I love this. I speak about this passionate all the time. I saw this Annatto plant. Oh, this is the Annatto plant. They have the bixin, and the bixin is used for coloring cheese.
It's a carotenoid too, right?
It's a carotenoid. So because it's a carotenoid, that's why. So...
Well, hold on.
Talk about the Vixen for a second.
Yeah, let's slow down.
Yeah.
Carotenoids.
Carotenoid.
Very big class of colorful compounds,
yeah.
which do include lutein and zeaxanthin,
Yes.
which are, other than being found in marigold, it's found in a lot of leafy green vegetables.
Yes.
Cool new source of it is duckweed. I'm very into duckweed lately.
Yeah.
He is. He talks about it all the time.
But it also includes...
Funny name. Really funny name.
Lutein, zeaxanthin, mesoxanthin, indicxanthin, fucoxanthin. You've probably heard of quite a bunch of these things. All of them are colors that impart pigment. And for the most part, it's like these orangey, yellowy, brown kind of pigments that you find in nature. Except for indicxanthin, which is like kind of pinkish.
Yes.
The one from prickly pear. So these compounds, they're antioxidants. They're the double-headed snakes that
Double-headed snake for sure.
that Barrie talked about earlier. But they're very good. They'll definitely quench free radicals. But a lot of them, like he was talking about, they will take place in some of all right, the whole concept of phototransduction, how fucking light makes this little film, this little movie go inside your head, is a wild concept in and of itself. I had a really cool conversation with ChatGPT one night asking about. I was inspired by some cannabis and I went down a rabbit hole about mantis shrimp and how they perceive vision. And I was going into a deep conversation about potential carotenoids that might be involved in their phototransduction and everything, but it had nothing to do with the carotenoids. It had more to do with the protein structure of the rhodopsins. But anyway, I'm going off the rails.
Cheese. Get back to the cheese.
We're getting back to the cheese. So Bixin, also a carotenoid, is massively harvested and farmed because it Velveeta. Okay, everyone likes Velveeta. Velveeta shells and cheese. Maybe you'd like to make some queso, melt some Velveeta, throw in some Rotel. The color of Velveeta is this chemical called Bixin, and Bixin comes from Annatto.
Yes.
And tell me, all right, so you're in Peru and Annatto is adjacent.
Yes.
Does it always grow in these types of climates?
Yes.
Where is the climate zone on Earth for Annatto?
The climate zone for Annatto would be more like something like Florida, but cannot be flooding with water like you have paddy growing rice like that. And cool in the winter, but not freezing. It grows where oranges grow. The better way to say Annatto grows where coffee grows. Very simple. So largely
and
tropical,
chocolate.
but doesn't have to be
cocaine.
entirely tropical. That's right. Mexico and South, but not far south to Chile and Argentina. Then
It's
it
too
can
cold.
grow. So not where grapes grow like that. But so therefore, there's a big range now. So it's a fat belt. So it's not
equatorial
really
for the most part.
equatorial like
So
that.
you have this aha light bulb moment when you see the Annatto
But
plant.
let me tell you how the aha came about. Because I got many things from plant to study. They don't come up with anything that I get aha about. First, I was a carotenoid chemist. And then I became a vitamin E expert. Then I gave up the ghost on vitamin E for the reason I told you, and I went back to the carotenoid, the lutein, zeaxanthin, and then I saw it in the marigold. Then I saw this Annatto plant. That's also a carotene. But the unusual thing is that this will be something I think Joey have not. You clearly is a self-taught, and then you seem to say a lot of things. Maybe AI help you, but when you say all these
Maybe
different,
I am an AI.
you have all these things, right? But I'm old school, I still don't use AI. I just read, But then maybe I'll read some AI stuff sometime. But
You'll have some great conversations.
but let me tell you how I did it. This will be now. I tell this, and AI is going to pick this up.
Once we put it on the internet.
That's how it works.
Now remember, think carotenoid. Carotenoid is so unstable. It's more unstable than omega-3.
It's light sensitive.
They're always protected. They have to be protected. For example, if you hold a shaved carrot, your hand is not staining. You have to cook the carrot. There's a lot of Italian sauce with tomato. The lycopene is not destroyed. So the lycopene and the beta carotene in tomato and in carrot, they're inside individual cytoplasm of the cell. Human have no cytoplasm, plant have cytoplasm of the cell. So, but when you cook them, they leach out into the oil, so you can see the oil being colored. Otherwise, so that tells you they are so unstable. They are there. Otherwise, well, Barrie, what are you talking about? We make Italian sauce all the time. The lycopene didn't go away. Yeah, they didn't go away because they're inside the cytoplasm. But you say human only know how to make liposome micelle. There's no big deal. That is inferior way. The plant makes it individual inside every cell. That's big deal, man. And they do it just by plant photosynthesizing like that. That piece.
The superior way.
The superior way, the original way, not man-made, And then another one.
We're working on it.
Think about an animal making it. Not a lot of animal make carotenoid. Crustacean.
Yeah.
Lobster, shrimp.
Sure,
They
yeah.
are usually yucky green, blue color.
Oh,
The
I forgot
moment
about
you put
cryptos,
moment you put them in hot water, they have this beautiful astaxanthin coming out.
Yeah.
So how are they protected? They are bound to protein. So the protein deproteinate and the color shows up. Otherwise, the protein alter the structure of the absorption. They're blue and green color.
Does
like
it
that.
function in those animals to protect the proteins?
No. The protein is protecting the color.
Okay.
The color, so that they have that beautiful greenish and blue color like that. But I'm only making the connection. Carotene have to be protected in nature like that. And then even in orange peel like that, there is a I've forgotten the name of it now. Beta xanthophyll, like that. So they also protected by the limonene, that good smell thing like that.
Once again,
so now
antioxidants.
all that to say, now you go back to Annatto. You touch the Annatto, it stains your hand.
That's true. Yeah.
Therefore, they are not bound to anything or in any cytoplasm. They touch it. The British nicknamed this plant the lipstick plant. I'm trying to find if AI or somebody can help me
Pull
to
up
know.
a picture of Annato, Eduardo.
The original convention of women's beautiful lips, red color, have come from Annatto. There are no lipstick like we have lipstick today. And the British nicknamed it the lipstick plant, and it's known for about 400 years, the lipstick plant. See, here's a picture of all the Annatto. They are stained. They are stained red color like that. And
Pods are beautiful.
Yeah, in the West, we use it to color cheese, sometimes curry, sometimes we put in ice cream, something like that. So this is some Annatto color that put in different protein. Cheese is the most common. See the bottom right there? Most common like that. Dorito chips.
Doritos for sure.
Like that for sure, but quite a bit. So now, this is my aha moment. The moment I knew that it is not bound to protein this and that, wait a minute. They must be a super duper antioxidant that protect the bixin from degradation of its color like that, because I had already known as a chemist that carotenoids are highly unstable. I was expecting it to be a polyphenol like EGCG, resveratrol like that. It was not. Then when I looked, oh my goodness.
Was it that day that you walked up to the plant and touched it like this?
Yeah. You can go to any Hispanic store.
I feel like I resonate with like, it's like you almost want to pull a gun out. Like, what the fuck are you doing? You're not supposed to do this.
Not that violently, but yes.
I'm feeling the emotion from like dropping all your vitamin E research, and you're like, hey. This is not supposed to be happening right now.
But when I saw that would be such an aha moment. When I analyzed, right, and I remember my chemist.
So what did you put some in your pocket and take it home?
No. I was going to do that, but I chickened out because the USDA couldn't fill it the form, and then I have to tell a lie, you know. But then I said, great. Many Hispanic stores here sell the Spanish word is achote.
Yeah.
And then the only Portuguese word, because of Brazil, they make a lot too, is called urucum. Urucum. Portuguese word, or achote. You can get this. So I grew this, and then they are viable. You can just put it in there. You should put this, and you'll forever.
You can go to the grocery store and you can buy a little McCormick tubs of it.
And then when you do this, first you cannot directly put in the sun. Put it at home, let it germinate, and go for about 6 months or so. It's about 2 feet tall, and then you plant it outside. When you're inside, do not put in direct sunlight because the chlorophyll get killed by the sunlight like that. But after it get to about 2 feet or so, then you put outside, then it loves a lot of sunlight in the place. Normal aeration will be good enough, not flooding in water, otherwise the root would rot, you know. So from there I found out my chemist did it, and he did not come back. Usually this guy in 1 week he'll come back, even less than 1 week. And that gentleman is John Foley. He worked for me, right? Then I said, hey John, what's up with you, man? This is 2 weeks, 3 weeks. Well, come back in another week. He's kind of indignant to his boss. He said, okay man, just give me the answer. So 3 weeks. The reason he was like that is because he could not believe it. He did the analysis. It was like today.
He thought he was getting like a false positive.
Yes.
Yeah.
So he got 10% gamma tocotrienol, 90% delta tocotrienol, and then there's no tocopherols. He said, you're not supposed to get things like this.
See, that's what's like so mind-blowing is you think like, surely this can't be correct.
That's why he didn't come back to me. But by the time I said, John, let's pull this out. We cannot be schizophrenic now. He said, you just tell me what it is. He said, Barrie, this is it. Then he still didn't believe it. He said, well, Barrie, we only have the HPLC. We should send it out to GC mass spectrometry. Fine, let's do that. He said, see, I had nothing to hide. So we sent it out. We were not making money. I was living from hand to mouth to do other things. I said, but we had it. So we sent it out, and then we came back. It was 90% delta tocotrienol. Then I said,
just natural.
Then
How much Bixin if you got that much tocotrienol?
Oh, we removed the Bixin because we didn't want it to mask it, right? Okay. So therefore, as far as the plant is concerned, the plant used the tocotrienol to protect the Bixin color. If you look at the fresh seed, it doesn't have a mesocarp. The flesh is called. Every fruit that we eat the fleshy part. It's a mesocarp. And in this thing, there's no meso. The mesocarp is air. Look at that in the middle. You see that? The part, and then see it's
Does
air.
It naturally split like that?
It just split like that. So, and then if you touch it, it stains you. So therefore, why does the plant make it like that? It looks so pretty, and it's no mesocarp.
Birds.
It saves its energy from making fructose and sweet thing and deceive the birds of the air, and because it's also very floral smell, so they swallow the seed and then poop and procreate the seed elsewhere like that. That's it. And then to do this, they have to make the seed look good and smell like a fresh fruit like that.
What's the natural pollinator of these? Is it just bees like everything else?
Bees like that. Okay. I actually have a picture of it. They didn't.
I was hoping that it would.
Well, if people see me doing it in a PowerPoint, then they probably steal it and they post it. I have one picture. I was in Indonesia. I fall in love with this plant. So every country I go, I've done it in Indonesia, Singapore, Philippines, Costa Rica, Dominican Republic, all over South America, everywhere. I go, and in the U.S. Botanical Garden, there's one in Bronx Botanical Garden, there's one in Tampa Botanical Garden, there was one in Galveston here, but then the hurricane came and then the tree's gone. So like that. So, but you can do it in your backyard. Just grow it. It will grow in Texas. Your weather is warm enough. You can do it. It cannot do it in New England. So now I got all this plant like this, and now when fall is coming, so I'm looking for some indoor place, but like that in New England, so that they can go indoor like that, so people can see. But I can still send you some like that. So
I will plant it. I will plant it and I will grow it. I promise you.
And then you'll remember this forever because we have Gigi to talk about still. Now listen. So then when I got this Tocotrienol, I knew it protect this. So that's it. And then, but I always have this floral note that I didn't want to say what it was. It's probably some terpenoids like that. Gigi has a floral note. I don't know anything about Gigi. I only know about Tocotrienol to protect the color. So the Gigi come later. It was when I tried to figure it out. I got to remove the color. You can't have people consume so much color. So I removed the Bixin color, and the industry sell the Bixin color. So we don't want the color anyway. So but then when we get the Annatto, after the color is removed, we just call it Annatto oil. So we have to carefully remove most of the color. And then we distill. We only use physical mean, no chemical,
I'm
no
going to pause you
solvent.
for right now because
Okay.
I want to get into this in the second segment.
Okay.
All right, we're going to take a break. We'll be right back after this. We're going to take a pee break, and then we're going to talk about like more of the nuts and bolts of American River Nutrition, how they make this stuff from Annatto, and then these two crazy ingredients, Delta Gold and GG Gold. All right, we'll be right back.
What's up, everyone? TK back here. I'm going to talk to you guys about the Supp Works podcast. For everyone that's been listening in since we started this thing in January, I just want you to know that we are so damn delighted to have you guys as listeners. The audience has grown, the engagement has grown, the viewerships have grown. It's been pretty wild to see. But with all this growth, it comes with quite a cost. And that's why the Supp Works podcast is looking for sponsors. Now, we have started off with some sponsors in the beginning, and they were great partners. But to be honest with you guys, I never really charged them because I didn't feel like our audience was large enough to basically pay for whatever cost I was having to expend in doing the podcast. And just so you guys know, these podcasts, they cost a lot of money. We got to fly someone in. We got to put them up in a hotel. We feed them. We usually take them out to some sort of event. It adds up. It costs quite a bit. And we subsidize these costs with sponsorships. So if you own a business, whether it's in manufacturing, you're a raw ingredient supplier, you own a brand, maybe you have some sort of supplement or CPG type service that applies to the supplement industry or the CPG industry as a whole, and you think that our audience, which is usually movers and shakers within the CPG industry, you're talking CEOs, owners of businesses, top sales executives, and then the whole gambit in between super users all the way up into founders of companies basically listen to our podcast. If you think that audience is for you and it would work for your business for us to advertise on this platform, hit us up. Just send us a DM, send us an email, tk@nutramedia.co, or send Joey a DM, and we can talk about our sponsorship packages. And basically you get this. You get a 1-minute table read where we talk about your brand, and obviously this has got to be something that we approve of and we support. But if there is a good partnership there, reach out. Maybe we'd be interested in having you as a sponsor. So if you want to sponsor the Supp Works podcast, just go and hit us up, and you can have your table read right in the middle of the podcast while we do our breaks, just like now.
Is an upcycled ingredient. It was a waste product to cheese.
Mm-hmm.
And we found that it had some value, so we started commercializing it. In a sense, like all this Annatto oil that's separated from Bixin is upcycled. So there's a sustainability.
I did like that visual you gave of saying like we searched, there was this much of this at 10%, and then there was like an Empire State Building spike.
Yes.
Like when you do that visual, I think that really helps people understand.
Now, on that one there, I know we already move on for that, right? I did say you can get it. Today, if you would eat normal food, you can get tocotrienol from nuts, and nuts that have some oil, like pistachio, like that. Usually monocots. That's a big word. Then like coconut, like that. But they have it even in dicot. Almost none in soybean, because soybean is a dicot like peanut, But you can see in corn. Corn is a monocot. You cannot crack corn into two like that. And you can find tocotrienol in there. But usually people think of getting lutein from corn. Then
Like, what's the level of tocotrienol?
very small. So I did one time did a study on normal American diet. It's about probably 2 or 3 milligram, but usually from vegetable oil.
And how many do you need? Should you have?
100 times more.
Oh, wow.
Like,
Yeah, 300 meg.
So that's why you should take it.
So if you were in Asia eating palm oil for food, then you probably get about 10 milligram. If you're in South America, because a lot of food have Annatto. Next time you go to Mexico, you have the tortilla check. They have a little red speck on it. And they pound the tortilla chip with Annatto. Annatto is so cheap. You just go buy and then you just do it. You get, and if you want to get this, it's just still a small amount. But remember, you're going to consume the Bixin with it. You can't get away with it because it's in there, right? So and YouTube have many examples. You put in about 1 scoopful, maybe 100, 200 Annatto seed. You put in vegetable oil, and you don't raise the heat to burning enough. You can see then the oil become red color. So when the Bixin comes out into the oil, all the GG and tocotrienol come on. Then you sift it out, throw the seed away. You don't need to eat the seed. And then you just use that vegetable oil for you doing your normal cooking. But whatever you cook with it, they all turn red. So you just have to be prepared. But if you do, then you have natural source of it from Annatto. If you go to South America to eat South American food, then you may get about 10 to 15 milligrams. They will be on the very high end on it. If you eat rice, if you eat brown rice, you'll get some tocotrienol. So if you want, you can discuss. I've discovered tocotrienol from 3 sources. We are only mostly talking about Annatto because Annatto is tocopherol free. I didn't use the word. Then for palm, it's typically 25%. And from rice, it's 50%. That's why I gave up rice. Because it's 50%, even
enough.
worse.
Yeah.
They even put all the brakes on like that.
There are plants with lower concentrations that are still commercialized either way,
Yeah.
just through their extraction methods and everything.
They even have done a Frankenstein work on it. The Korean have done it like that. No need to cover this, but it is true. After they learn that tocotrienol is more potent antioxidant to tocopherol, so they genetically clip the gene of the soybean and of the rice, and then they make the soybean and the rice, now they're Frankenstein. So they only make tocotrienol and not the tocopherol. And when they do this, the fat in the soybean and the fat in the rice bran, they have longer shelf life. So the whole study is to show that. See, we even show genetically. If you mess up the gene and they only make tocotrienol, and then the soybean will last longer and the rice will last longer. We say, wow, this guy has too much time in his hand. We already know that from other study that we don't need to do this. So therefore, as far as the antioxidant as fat protection is concerned, tocotrienol is head and shoulder above tocopherol. So like
What about tocopherol inhibiting the benefits of tocotrienol?
Oh, the inhibiting.
Did we get into that at all?
Well, I would assume that because they're so similar, their molecular profiles, that just like beta carotene and lutein and zeaxanthin, that there would be some sort of competition there.
Yeah.
That tocopherol is going to compete for the same kind of transport
Yeah.
activity as tocotrienol.
Normally, I think scientists would consider that. Also, there's possibility of synergism, but our holistic community generally think that if one is good, then a whole mess of them together would be better. So that is kind of like an axiom. You know, if you think holistically, people think like that.
Sure.
Generally, it is true, but when it's antagonistic, then we have to shout out. And this thing is then, because if we don't, then I will never get the tocotrienol to work properly.
Okay, since you're a carotenoid guy, the military ran a study back between World War I and World War II, and it had to do with using regular retinoid.
With your hands up to the mic.
Oh, are we recording?
We're recording. Yeah.
Just because?
Y'all started talking and getting deep into it, so.
Might as well.
Well, there's like an agenda. All right, so the story was the military was running a study using something called dihydroretinol instead of just regular retinol for vitamin A. And they gave these soldiers a diet that was deficient in vitamin A specifically, just to completely deplete them of any vitamin A they had, and that they would just, through metabolic turnover, just kind of deplete themselves of what they had. And they supplemented them with dihydroretinol, which is found on the retinas of fish that live in like muddy rivers and stuff, and like India, like catfish. It's on the retinas of catfish. So they're bottom feeders and everything, really murky waters. And they do that because it shifts the frequency of light that they can actually perceive with the rhodopsins. So if you have a lot of dihydroretinol on the retina instead of regular retinol, that they can see closer into the near infrared. And they ran this study on soldiers, and they gave them dihydroretinol to shift their vision, and it worked. And they were gonna employ this as like a countermeasure so they could see better at night. But it was like 5 years after that night vision goggles came out, and they just completely scrapped the whole thing. And that's another case of like this antagonistic relationship. Like if you have one, you can't necessarily have the other. But in some cases, like you can replace what's in there endogenously with like this other more superior form, or in that case, just a different form of the same kind of vitamin. And it'll produce like a kind of a different effect, but it has the same kind of function.
Wow. I have not read that, so now I'm going when I go back, I'll read that this kind of study.
I think the Air Force did it. Yeah, it was a really cool. I tried to make a product that had dihydroretinol in it like years ago.
So it's like supplemental night vision?
Yeah,
Exactly. Yeah.
I'm going to have to try that.
For hunters.
For hunters,
Really?
yeah.
Yeah.
Wow.
For guys
cool.
trying to hunt at night. Yeah.
Oh, no.
That's cool.
And there are like hunter supplement brands. There's one called Mountain Ops. It's one of our clients.
Does that product exist?
No, not yet.
Yeah.
Well,
I'm curious.
He will be the person making
Well,
it.
I had to make a soft gel, and that was my like main holdup. Like the manufacturer I was working for at the
Well,
time.
you
was
didn't
only
use
capsules.
vitamin E, dude.
Well, it's not the same thing. It's not the same thing. Like they're similar, but they're certainly not the same.
No,
but like
Liposomally.
the vitamin E would not increase the vision like you said. The retinol would.
No, but you
because-
could use it as a liposomal, like.
yeah.
Oh, that would be good.
protected.
Now, University of Missouri optometry department had two studies, and I followed it a little bit. And basically, they say that when they were given vitamin E and in tocotrienol form, they would be able to protect the retinal film better. It's also laden with DHA there.
Well,
Except
this
it's a
is-
very thin film. You
This
see.
is part of why I reached out to you guys in the first place, because I was putting in a grant proposal to NASA, and it was for what they have is called the spaceflight associated neuroocular syndrome.
Wow.
And what happens is and I was looking at vitamin E for obviously the radiation protection measures and all the other stuff that's out there. But it's funny because like you guys never reached out to me. I reached out to you for both the Tocotrienols, and I reached out to you guys for the GG because I've heard about them in like the literature, and I was like, I got to find out who's got this. I got to find out who's got the best. But that product was going to be like a combination of lutein, zeaxanthin, and this stuff, and potentially putting it in like this colossally expensive liposomal form with like all kinds of like water soluble stuff on the inside. And I was thinking of like, how could you like intelligently structure a liposome where you could trap lutein and zeaxanthin in between the bilayers, and then have this tocotrienol also in the bilayer itself, so it has this antioxidant potential. It's delivering this massive payload of like this great basket of goods to the retina. Because what happens when you're in zero G is like the blood that's usually in your feet is no longer in your feet because you have no gravity, so it all shifts toward your core, and it increases, you know, your intracranial pressure and your intraocular pressure so much where like the retinal nerve starts to push in on the back of your eye itself, and it shortens that distance between the lens and the retina, and it makes you farsighted. And it happens disproportionately to like middle-aged men. It happens disproportionately left and right, so it affects one eye more than it does the other.
Yeah.
And they're looking for different methods of combating this.
In space. You got to back this up.
Yeah, in space.
For people who do
Obviously,
long-term
space flights.
space flights in the ISS, this is an issue.
astronauts, they start to degrade their vision, correctly?
Yeah, but it does kind of self-correct once they come back to Earth because the blood goes back down and it's not a problem.
But if you want to do long-term space flight,
a year
say to
or more,
Mars or something like that, it's highly problematic that you lose your vision over
Wow,
time.
they have a lot of. I know that they also do work muscularly on atrophy.
Yes.
They begin to atrophy because there's no weight on them.
So,
Oh,
so
man.
NASA put out.
I know we can go. I can
get
tell
started.
you this.
So NASA basically put out a PSA that they're doing grants trying to figure out a way to combat this, and Joey
Well, if
Joey
you know,
was interested. That's why he reached out in the first place.
So if,
Yeah.
if you get further on this, we are an American company and we can make this. You know, we haven't. The only one that we have done, and it was an indirect thing, was with the U.S. government for sure. Is in the radiation piece. But other than that, we didn't do. I don't have any contact.
Do you want to
in
just
that
get
stuff
into
that.
like how wild those studies got? Because you guys didn't just do it in vitro. You did this in rodent studies. Mm-hmm. You did it again, like going further and further up the model system chain, all the way to non-human primates.
Yeah.
And the only thing, I think it was the non-human primate study that actually made Tocotrienol something that I don't know what the program's called, but like it's in the U.S. stockpile for radiation countermeasures.
Oh, I can tell. Since we're on this, I'll tell you how it happened. The year was 2010.
Yeah, it's a pretty fresh.
Yeah, pretty fresh. And 2010, and I read some papers. The institute is called AFRI, AFRRI. It acronized for Armed Forces Radiation and Radiobiology Institute. And it's part of the Uniformed Services University in Bethesda, Maryland. This is a university United States government sent the armed forces to get master's and PhD degree. This is not where they train them to be soldiers like that. But so everybody there, they all have uniform like that. So 2010 came. I read some papers. Oh my goodness! I didn't know anything about Tocotrienol have radiation countermeasure, very militaristic term. So I emailed them, talked to them, and then they said, "Oh, Dr. Tan, coincidentally, we are celebrating our 50th anniversary." So I said, "Okay, this thing must be declassified, whatever it is, like that." So I went, said, "You must bring your passport." So they knew that I was not born in this country. It's no problem. They only allow U.S. Citizen to go. So we went. So when I went in, I mean, there's a lot of fast learning thing, you know. Now I realize the reason they have this university is because they're doing research that a civilian university, however famous they are, cannot do. This is a place that did Ebola virus. Mm-hmm. You follow me? Mm-hmm. These are the places that they'll do viruses that will kill the world fast in biological warfare. They cannot do it outside, you know. Some dude just walk away with something, or some pen have scratched on something. Then this is seriously bad news. This is worse than anything you can imagine as mercury lead toxicity. You know, this is a biological thing. And radiation.
We talked about that on the last podcast.
So I went to this lab. So we heard some lecture, went to this place here. Just hear me out on what the lab looked like. So I went there, and it's very eerie. There's nobody there. So I'm looking at it. There's a center core. They did the gamma radiation. Gamma radiation kills.
That's bad stuff.
That's bad stuff.
That's the worst stuff.
And then the whole thing, right, is 30 feet down in water circulating. 30 feet down. Olympic-sized swimming pool is not 30 feet. Then I said, wow, this is big time different, man. And then, so you can go 1 story, 2 story, and 3 story down. Just the lab that they facilitate this. So now... So I got it, you know. And the professors are not called professors; they're captain, lieutenant. So they all salute each other. Then, so I just feel a little bit out of my skin, but I got the stuff that they want. So they, in big picture, is they tested thousands of compounds. The program started a while back. If you remember, this is not making a political, just the facts, right? The younger Bush said that there were acts of mass destruction in Iraq. Remember, there were none. So we were very concerned about this. And usually,
they're concerned about dirty bombs and the radiation fallout.
Yeah, and then we have to put first responder there. So if they go in most of the time they come out, they're living dead. You know that they found this thing out in Fukushima, even though they're like that. So they have people going to do it. When they come out, they're still living, but they're already living dead.
Yeah,
because they already radiated so much.
They're walking.
So
So when we were talking about lipid peroxidation earlier, and we were talking about like the more valuable stuff being closer to the nucleus of the cell. This is so when you deal
different.
When you deal
this
with
one
radiation,
is not just lipid oxidation. This
They call
already
it
they zap into the DNA.
linear
the person is
ionizing
gone.
radiation.
Yeah.
So this is a particle going a gazillion miles an hour, and it just doesn't give a shit, and it goes zoom, goes all the way through every single part of the cell, and doesn't care, and it oxidizes everything in its path.
Yeah.
Everything in its path, and this is how they do the clinical studies.
That's right.
The Brookhaven National Laboratory.
Which is why in this study
They put
here,
a rat at the end of a track, and they will shoot a particle of radioactive material zoom, through its whole body.
So
It's still alive. It's just like, what just happened? I'm burning on the inside. Like,
then they measure them they measure them. They feel that if radiation damage happened, it's supposed to be 30 days. So they have this survival thing, and they measure 50% survival like that. And most of the time, if it is without tocotrienol or any substance, they all would die about 12 days or so. You can see they're all gone, you know. And then they add tocotrienol then longer, and some of them survive 50%, 70%. So they have indication on this. This is a total radiation intended to kill. Very serious stuff. So I already carry in my mind radiation oncology. And when I asked him, he said, Dr. Tan, he said that we don't do research. That's not the Department of Defense funding research. He said, however, that's important. Somebody else have to do this. We don't do this. So therefore, when I went to look at them, I'm only studying what are some take-home things, even though the radiation was very serious.
Yeah.
But I tell you how, they do thousands of compounds like that, and the department is alive and active. Even though we don't have Iraq on this, we have Pakistan, we have India, we have China, we have North Korea. All of them do this. You know,
still
so they're not going away,
stockpiling
and we do
countermeasures.
it also. But you know, the big country who are rich are not doing this. Germany and Japan. Like they have enough money to do it, but they don't do this. But the threat hasn't gone away. So radiation countermeasure is alive and kicking, and whatever other secret thing they don't tell, we don't know. But for the ones that we do know, they test thousands of compounds, and 6 of them got into a place that most of them other did not. I remember some of them, and the 2 that I remember really well is delta and gamma tocotrienol. Would you believe it? Delta tocotrienol and gamma tocotrienol. I had nothing to do with it. They were already doing study on the gamma tocotrienol, and then they say a genistein from soybean, and then there's a few other ones too like that. But the one that worked well is this thing that they inject onto people. It is.
I forgot the name. I tried to look the name up earlier.
Aminophysistine or something. They inject on people.
Aminophosphine.
Phosphine. Thank you. But it's very toxic. But they still have to give it to people. They're people who go into radiation oncology.
But what the thing that was interesting to me is the aminophosphine and gamma and delta tocotrienol, they activated the same cellular mechanism.
Yes, and the tocotrienol have no side effect. So now I tell you why. If you look at the literature, they only now stay with gamma tocotrienol. And say, for example, there are about 100 studies or more gamma tocotrienol, probably about 6 studies, 10 studies or so on gamma tocotrienol. I tell you the advent of that and the story how that. When they get in touch with me, they were already doing work on gamma tocotrienol. They have continuous, huge amount of funding from the Department of Defense for obvious reasons.
Where were they getting it? Because like you pretty much had the whole supply.
We got it from we gave it to them later. Okay. Initially, they get the gamma tocotrienol
They're
from
making it
palm.
synthetically.
Palm.
Really?
Yeah, palm has about 45%.
So they were just purifying it.
And then purifying it, and then it's expensive to do, but they need this, right? Yeah. So they did that, and then it's obvious that they'll check gamma because you don't check for something. But it's only 1% because it's forever to get that. You do the lowest lying fruit, check gamma, and then they found out gamma works, tocotrienol worked, and alpha tocotrienol didn't. But they didn't check delta because in palm, delta tocotrienol is only 5%.
It doesn't exist,
it's very
really.
like this. Then We show up in the scene. He said, we can give you the gamma tocotrienol because we have 10%. However, we would love you to try delta tocotrienol for no other reason that for every 100 grams, I got 90 grams of the stuff. He said, you have to show me. Right? And they said, okay. So they were convinced. We were just talking to them. They did. And then they said, while you're doing that, can you also do Annato tocotrienol because it's 90-10, right? And they did all of those. They published all of them. And then the shorthand is delta tocotrienol was more potent than gamma. And then a year or two later, they say, sorry, Dr. Tan, we abandoned your delta tocotrienol. It's better because, listen to this. And this is technical, not scientific, technicality. They have already done, to get FDA approval as a drug for radiation countermeasure, very specific, you must have 2 species of animal. And it is not true that FDA only approve drugs if they're done on human being. You do human being, half the human being die. What kind of study is that? So you can't do this, So this kind of study, you can do this.
So
they thought of it. This is called, you can Google, it's called the animal rule of the FDA for approval. So they have rodent, and after rodent, you must have a larger than rodent, and the species they use most resemble human being.
Rhesus monkeys.
They call it non-human primate. They did that, and it's very expensive. So they have 1, 2, 3 studies on that, and they have already done that on gamma tocotrienol, and they already got approval from the FDA that this is approved as a drug for radiation countermeasure. And then, as far as the Department of Defense is concerned, they have much more money than the Human Health Services, for which they're top here, and FDA is way in the bottom. USDA is higher. Do you know that? Like that. So, but the Department of Commerce have 100 times more money, and they are the one that fund the study. So they say, well, whatever the FDA give approval, that's what we want to do. So politically, he had to stay with that. But they did 5 studies for us before they stopped, enough to show us that delta T3 worked like that. So this year,
That's just our government working for you. That's how the
but-
government
but
works
that
for you.
takes forever.
And I'm going to close the gap for you. This year, although I kind of have mixed feeling because of the paper when it's published, I'll tell you the paper first, and then I'll tell you where the paper is published. This group of researchers capitulated all the thing that I said and said that this delta tocotrienol is most potent. It did not get approval because it did not do the non-human primate. They did the non-human primate study, and it was only published this year. So now they are on track to get approval, but it's not done in the United States. It's done in China. So
Of course.
you can read it 2 ways.
Yeah.
They're done in China because
It's
what are they
competitive.
doing it in China for? What else? So there are other stuff, but nonetheless, they published this paper. They clearly showed it. So when you get to radiation that are so damaging, it could be also true for radiation oncology, but except in radiation oncology, they don't zap you in the whole body. They only zap the place where they believe is the tissue where there is tumor, because they want to kill the tumor cell. So it's laser sharp. But of course, anybody you know that have cancer, you know this. If a woman have breast cancer, when they go to radiation, the breasts don't look pretty. They're going to be 2-3 times the size. They're seriously inflamed. So they did kill the tumor, but everything else is also messed up like that. And my radiation oncologist always tells me, when you do radiation, they have several rounds of this, and usually it goes for 5 to 7 weeks. The moment the white blood cell increase, they stop because the body react and the white blood cell is the white blood cell drop. Sorry, not increase. Drop.
Right.
When it drop precipitously, well then life as
not
it
fighting
exists,
back, yeah.
it's not good. They have to stop like that. So they give them something called Neulasta, which is a drug that Amgen make to boost the white blood cell. That is the context of radiation oncology. So this radiation countermeasure, they also study the white and red blood cell. So at the time, I have a chief medical officer, and the guy is a radiation oncologist. He picks up stuff I cannot pick up, and that is his wheelhouse. Perry, did you see this? This is on the control side. Forget the one on the radiation side. So they have control rat, they zap it, and then they have control rat. They give tocotrienol, they zap it, and then they have control rat. They give tocotrienol, they didn't zap it. So they have positive and negative control. He said, just look at the control rat and the control rat that were given delta tocotrienol. When they're given the our delta tocotrienol, he said that the white blood cell increased. Hey, this is what Nuvesta does. He said that, so then this delta tocotrienol is good for giving to people who have radiation oncology. See, that was it. But right now,
So this
I'm
is how
not
it
being able
crossed
to
over.
do. So if you know of anybody, I don't have the money to do this. MD Anderson can do the study. They gave people radiation oncology. They have to do this. As far as cancer is concerned, you poison, you cut or burn. Poison is give them chemo, cut you just surgical, and burn you have radiation like that. And so this is one of the three main tools to go after cancer. So I would love to have a study where people go to radiation and you gave them tocotrienol with radiation.
Would you pre-treat them?
And you pre-treat, but remember, tocotrienol directly bring on apoptosis of the cancer also as well. So if you do this, and it have no toxicological effect. Currently, I'm segue now. Currently, our large clinical study on people with pancreatic cancer is being done now in Tampa. The clinical trial, you can go to clinicaltrials.gov, you can suss out the paper.
And they're getting radiation therapy?
No radiation.
No radiation.
It's surgical. It's
Okay.
surgical removal. When you can remove it surgically, you do this. Hard to remove surgically if it's a brain cancer like that. But if it is inoperable, and then you do radiation. If you is inoperable and you cannot do radiation, then the last thing you do is chemo. But that usually is very serious, like stage 4. Then you got nothing to do. Those stage 4 study, nothing to do. We have those clinical trials in Denmark. The one in Tampa is stage 1 and 2, where they can be surgically removed. So the professor gave them tocotrienol only 2 weeks. 2 weeks before and
300?
surgically removed. 800 milligram. So 400 milligram 2 times a day. But for normal people, the 300 milligram 2 times a day is fine. But he wanted to do. He based it on his animal study. But when he did that, why is he doing that only for 2 weeks? Because just think of how he can get tissue. He's removing the surgical tissue anyway. So when you cut, you don't just remove the tumor. Some of the fresh tissue is also removed. So he found that the tocotrienol did not mess up the normal tissue.
Yeah.
He found out that the tocotrienol directly killed the cancer. Man, this is, ladies and gentlemen, you're hearing, this is as good as it's ever going to get. We're talking about a supplement that can kill cancer like this. Now, if I can show that it can do radiation, then it's a different. Remember, there are 3 ball game how to go after the cancer like that.
It's weird when it comes to disease states like this. And for the record, we do have an FDA disclaimer at the beginning of this show.
Okay, all right. We are not talking about this on the
making me
cancer
a little
thing.
nervous.
We do have the disclaimer at the beginning of the show, though.
Having said this, though, I am not claiming this to you Google and do PubMed search. These are all published.
So you'll see it for
You can
yourself.
figure it out
Yeah.
for yourself like that. So I'll go back to you. You're gonna have asked me other questions, but this is the cancer piece. The cancer. I'm not.
Well,
giving,
I think that the applications there are solid. I mean, especially
Yeah.
for people that are undergoing radiation therapy.
Yes.
That makes a lot of sense.
Yeah.
What I approached it for, because aside from dirty bombs and cancer, is the space flight environment. And those people are getting hit with a whole variety pack of different types of radiation insults,
yes.
from like galactic cosmic rays,
Yes.
protons, heavy ions, like
Yeah.
everything is coming at them. And they don't have a choice of whether or not they get hit with it, because it goes through the hull of the ISS, it goes through their bodies, and it just keeps on going. And I think it would be interesting if we could convince some people within the spaceflight community to do a rodent study. Maybe they could just do like even a cell culture study or something to show that these like heavier particles and stuff can somewhat be mitigated by tocotrienol, and I think it could. Because like I did the comparison earlier with when you have like a linear ion that's just going through a whole cell and it oxidizes everything along the path, there's got to be some sort of repair mechanism there. And the mechanism that probably increases the white cell count, like you were talking about, is the stimulation of something called granulocyte colony stimulating factor, which would increase the white blood cell count.
Yes, it's exactly GCSF.
Yeah,
did that.
It's a big repair mechanism.
It's a huge repair mechanism. I think that before I retire, and if I were to do another clinical study on Tocotrienol, I'm focusing most of clinical study on GG now. I would like to do that, to have that nailed down to do this. And actually, a lot of
just a smoking gun between GCSF and tocotrienol.
Yes, on GC, and the one that is ongoing. By the way, a lot of our tocotrienol study is done in your lovely state. The one that is the last one that is ongoing because of COVID, it took a longer time. We are using tocotrienol to severely reduce inflammation of men and women who are obese. It's done in Texas Tech University. Love it.
Cool.
So
There's more fat people in Houston.
we need to circle this to GG.
Okay.
And why you have this line of supplements.
So yeah, you got the Annatto. You got the Annatto oil after they pulled the Bixin out of it, and they used the Bixin for making Velveeta cheese and whatnot. And you've got this Annatto oil, and then you are through the process of molecular distillation, which. All right, so for those of you who don't understand, distillation, this is like making whiskey or anything like that. You're evaporating things off and you're purifying those things that vaporize off. So when you've got Bixin, say they evaporate the Bixin, it is a certain molecular weight, and because of that, it's going to evaporate off at a certain temperature. Heavier things probably require a little bit more heat, and they're going to evaporate off. And you can collect these things based on the heat, based on the type of pressure that you have inside of this vessel that's like more or less like you could do it like a round bottom boiling flask kind of thing. So you're heating it. In the solution, whether it's oil or whatever, it vaporizes. These things condense down a condenser, and you collect them at different temperatures. So the last thing that you got after you pulled off the tocotrienols was that stuff that was sitting at the bottom of your flask the whole time, and this was the GG. And this is a really interesting thing because, like, we looked at the structure earlier of tocotrienol, and it's got the ring system and a tail. GG is just really a beautifully symmetrical kind of complex tail.
Yeah, and it doesn't have a ring.
And I reached out to you guys because I took some inspiration from another brand that was like kind of like a no-name brand at the time, but when I came across them, I found them to be like remarkably insightful, super innovative, and I felt lucky that like nobody knew about them. And if you guys want to go check them out, it's Antaeus Labs, Antaeus Labs. I don't even know if they're still in business, but they did have this stuff called geranyl, and God knows where they were getting it. And I was like, I got to have me some of that because they had a really cool write-up, and it talked about the mechanisms and the different things that. All right, so first of all, you're going to be mind-blown because geranyl does a lot. But
that's the GG audience.
Yes.
That's where we're getting GG from. We've said GG lots of times. That's what he's talking about.
If you come across this and you're reading it, you're going to say, oh, fuck, I don't want to read that. But geranyl. Okay.
Yeah.
Just break it down, sound it out.
It looks weird.
But we call it GG for short.
I was looking at it earlier. I was like, that's hard to say.
Yeah. But anyway, this stuff, it has many different mechanisms. What interested me was that it had a negative effect on this pathway called atrogen-1. Atrogen-1 is a muscle atrophy gene. It's part of the ubiquitin proteasome pathway, which is like this enzyme system that really is responsible for eating up muscle tissue if you're starving and you need calories to make energy, or if you've got muscular dystrophy, or if you're undergoing cancer cachexia and you've just got generalized muscle wasting, HIV, AIDS, all these different applications where your muscle is just getting eaten by where you get hangry and you're like, my stomach is eating itself. Well, it's actually eating all your peripheral tissues. And it does this through the ubiquitin proteasome pathway or through overtraining. If you overtrain and you don't recover well enough, then your muscle's going to start to break down because you're just beating it up all the time, and the way that you're only going to derive energy is through this ubiquitin proteasome pathway. This is the same way that HMB works, but not exactly. So the ubiquitin proteasome pathway is really complex. There's a lot of different characters that are in this cast. So it's called the ubiquitin proteasome pathway. So obviously that indicates it's a whole family of different processes that are going on. And from the research that I read, I was going to do a supplement lab on this, and I never filmed it for Anomaly. Estrogen 1 is, I guess would you say it's a promoter, or it's like this gene pathway that includes several different other characters? One of them is called TRIM63 or MURF1, and then there's another one that I can't even remember the name of. But I think that these things might actually even be separate and or complementary to the same way that HMB stops muscle breakdown. So there's some interesting potential synergy there that is yet to be discovered.
The HMG CoA, there is something there that connects with HMB, but right now we should stay with GG first. If it connects, then it's great. Then people immediately can do the combination. I think the good step to stand back, first, the obvious. American River is the first company that make GG, and I'm lucky to discover it from Annatto. Some other time you can look at the structure of tocotrienol. The tocotrienol, the whole structure of GG is inside the tocotrienol structure.
The isoprenoid tail.
Yeah, the whole tail, and then including into the first ring.
GG, geraniol, you could see the molecule.
You can see that. So,
or just type it
Wikipedia.
in Wikipedia.
Yeah.
So you find
wait,
this GG.
even on this one here, you see that? See the structure there? So that
double bonds to the right,
Your three
the
double
tail.
bond there, like that, and then if you look, just ignore the antioxidant ring. If you ignore the antioxidant ring, the phenyl ring, like that.
If God looked at this molecule and said, "Can I have some more tail?"
So that whole tail is actually GG. Just forget the ring, the first ring, then it's GG. I think that's good enough for now. So in the plant, they use GG. This plant, they use GG to make vitamin E. Even tocopherol comes from GG, and then the plant is able to desaturate. I don't know why the plant makes tocopherol. It does that. I said that I would mention one or two things about the
Do you
plant.
think plants kind of have a weird advantage that they can make their own aromatic antioxidants?
The plant can make a lot more things than animal can. Like that, for example, the entire chlorophyll. Next time you Google the word chlorophyll, no chlorophyll, no plant, no photosynthesis. A chlorophyll has a tail. The entire tail is GG. And then all the carotenoid. The two GG molecules together, carotenoid. We're talking about carotenoid the whole time just now. 2 GG, C20, 20 carbon, another 20 carbon, 2 GG. Human can never do this. You have two GG stick together, suddenly 40 carbon. 40 carbon is the signature of carotenoid. Beta carotene, lutein, astaxanthin, lycopene, blah, blah, blah. The whole thing is C40, like that. So that's the plant kingdom. No carotenoid, no chlorophyll, no vitamin, then it's no plant. They can't photosynthesize. That's the plant. That's amazing. So GG is the last common step between the mammal and the plant.
Let me ask you something. If you're saying this is true about chlorophyll, is this probably the same thing about vitamin B12 too?
No, not vitamin B12.
Because it's got the same kind of like structure as chlorophyll does.
Some aspects. I will take a closer look. Vitamin B12 is very complex. The molecule is very very complex.
Yeah.
I'll take a look. If it is, I'll come back to you. But chlorophyll is essential. I mean, the other one is essential vitamin, but no chlorophyll, no photosynthesis. Like that. But interestingly enough, if you flip it to mammal, green and red. And the red is hemoglobin.
See,
the
we're on the same page.
GG is in the hemoglobin. Isn't that interesting?
Well, heme itself looks a lot like chlorophyll. And that's why I asked you about vitamin B12, because I'm thinking of this same chain. Okay, so the GG chain comes off of the chlorophyll.
Yes, they come off of the chlorophyll, and the GG is in. Now, this
in the
heme thing,
B12
you know,
gets granulated.
I mean, when you think about it, you'll be darned. You know, this molecule is very primitive. It's been there a long time ago. The GG that is in hemoglobin, the GG that is in a very fatty material in the brain called dolicol, they're all cis GG. This is to answer the question, now, do we need cis GG? Like that?
Do you want to explain cis and...
Okay, so in these double bonds here, these... Well, I guess you could say these could be cis or trans, depending on how you look at
cis
it.
or trans. This
so-
is trans now. As a structure, it is trans.
I'm going to do some stuff with my fingers, so bear with me. Double bonds exist. Now, if you have other parts of this molecule that are bonded on the same side, you have a cis bond. You can consider this in cis and transgenders. Same side, right? Cis. Now, trans is on the opposite side. So if you have the molecule going in two different directions, then the continuation from that double bond is trans. But if it's on the same side, you got cis, opposite side, you got trans. Now, on this one, it's kind of interesting because you've got what I guess you could say it's like a trigonal planar isopropyl kind of structure going on between these, or I guess there's four different carbons. Now, these little sticks going off of the main chain, those are methyl groups. Now, about that double bond, if you were to consider those methyl groups, sure, that's cis in that orientation. But if you're going about the rest of the chain, so along this x-axis instead of the y-axis, those would be trans double bonds. And for the most part, geranyl is trans. And you can even see this on resveratrol. Most people are like, oh, we've got 95% trans resveratrol. It's because nobody has cis resveratrol anyway, because plants don't
That
really,
is true.
they don't really do that.
Yeah.
But some people brag about that.
I mentioned the trans thing because I felt that at the beginning when I introduced this compound, people understand CoQ10 and MK menaquinone. And the
It's
human
vitamin K2.
K2. Vitamin K is phylloquinone. It's saturated tail. Almost the talking is analogous. The saturated tail of vitamin K, which we call it vitamin K1 now. It's called phylloquinone, and that's a Nobel Prize that was given for that. It helped the animal and the person to have clotting. Otherwise, we bleed to death and have hemorrhage like that. Then we noticed that our body also have vitamin K2. And the word menaquinone come from microbiologists because when they discovered this vitamin K2, they found that it's under fermentation. So now, I'm going as I go on and talk about it, it's begin to be garbled. And then in our industry, everybody know menaquinone, and usually they refer to MK7, longer tail, and then they say by fermentation. And then the yaka, they're going to bring out the natto, the Japanese natto fermentation, kimchi fermentation, cheese fermentation, kefir fermentation, yogurt fermentation. So if you think about this stuff, then they are menaquinone, vitamin K2, menaquinone, the long chain, because the bug love to make long chain, 7 to 13, MK7 to MK13. So now, that's the context. So now, I am intrigued. I see animal meat. When you study the meat, they have vitamin K2, MK4, and no MK7. I said, where does the tail come from? Then I said, if you look at a phylloquinone, exactly that length of tail, and then you look at MK4, exactly the same with the double bond. So it's almost sounding like tocopherol, no double bond, tocotrienols, double bond. Then I said, man, the whole tail of MK4 is GG.
Which does have the double bonds.
They have the double bond, right?
It's the same kind of analogy.
Then I said, how did the MK4 become like this? Well, means because they eat meat. I said, yeah, but vegan also have this, like that, have this. Then I said, wait a minute. Then people begin to do study. If you take normal vegetable, green leafy vegetable, dark green, lots of vitamin K, K1, phylloquinone, like that. And then when they did animal study, this is such a darling. When I read it, right in the gut, we have enzyme that cleave off the tail, cut the tail off. And then the tail flushed away. The ring, sometimes people refer to vitamin K3. You cannot find in normal abundance. And the FDA don't approve vitamin K3 before 2000. It actually caused lysis of the red blood cell. It's a bad word. That means it destroyed the red blood cell. You don't want that,
Explodes.
So, but anyway, but if you take phyloquinone K1, then the ring goes in, and then magically they become MK4. So in about 20 different...
So once again, this is that fermentation step going on with the bacteria.
And it's no fermentation. No, all the other manoquinone K2 come from fermentation, and that can only be in the colon. With the lone exception, you have the Lone Star, Texas, lone exception, and that is MK4. So the ring goes in, and in 25 different organs, it grabs an endogenous from within the body. Remember, GG is a compound our body makes. Grab a GG, stitch onto the ring, so now you have MK4 everywhere. So take a step back. Don't think supplementation. Don't think you can help company A, B, and C. Just think of it. Before you and I were born, in the beginning of time when they were Homo erectus, they're not even Neanderthal yet. They already were doing that. So therefore, evolutionarily, our body have been preserved to use the vitamin K our body needs, and that vitamin K is vitamin K2, MK4. Forget MK7. It was not. MK7 is for fermentation in the gut to give you good gut like that. That is true. That is good. Like the bug makes them. But if you have fermentation inside your body, that's bad news. So this is actually biochemical synthesis by your human body. And why does it do that? I think it does that is because phyloquinone can only get into homeostatically, only so much amount of phyloquinone can be there. Because if you have all the phyloquinone go in, well, think of all your vegan friends. They will all clot to death. Have you ever thought about that? My vegan friend don't clot to death.
That's true. They don't. They eat a lot of K1 and they're not clotting
Yeah,
to
they're
death.
not clotting to death. Therefore, think about it, my friend. So that means that a fixed amount go in to prevent clotting. Agree. We don't want to bleed to death, Agree. So most of it is MK4. So now it begs the question. I'm trying to justify to you strongly why your human body needs GG. So the way to answer is, if we make MK4 and CoQ10, figure out what MK4 and CoQ10 does. Then you know why GG is there. MK4 essentially shuttles the calcium from soft tissue to the bone. In the human body, it's a very precarious seesaw. The fulcrum is here. Bone, 95% calcium. And then the soft tissue, 5% calcium. Off-kilter is 6% in soft tissue and 95%
and then
94%.
you get heart disease.
That's already off-kilter. Well, that's a very precarious thing. If it's 50-50, then it's easy to balance. But a 6%, 94, that's not easy to balance. And what makes it a balance? MK4.
Is this where we pull up that product that you made called BRF45?
I just told you the main thing. We haven't even got to the muscle thing yet. The muscle thing is big deal, by the way. But but this is just this. Just get this in. Without MK4, we're gonna have calcification of the artery, arteriosclerosis. Bad idea. We're gonna have calcium in the kidney stone. Bad idea. And then we have gallbladder, gallstone. Bad idea. We want the calcium to be in the bone, and MK4 does. In Japan, 45 milligram MK4 is to prevent osteoporosis. Hence, the BRF, the Design for Health made, is 45 milligram. That's it.
There's a product by Designs for Health called BRF45.
BRF45.
And a lot of his logic he's talking about right now is in
45.
that formula. There it is.
Wow, you can pull it up so fast. I think
Pull
that...
up the supplement facts real quick.
I think that...
I had a lot of questions about this because most of the
ask
time...
me.
When you see K2 in a product, you're looking 200 micrograms. That's the usual dose. Now, you've got it in here at 45 milligrams, but you've got the GG in there too.
Yeah.
And you've also got K1, which I also found to be really confusing. So now that you've told this story...
I will explain.
So it seems like the microbiome chops
Yeah.
the tail off the K1.
Yeah.
Uses the GG to make more K2. And GG is made endogenously, but obviously you've got supplementation. There's a lot of ramifications here. Okay, and I kind of want to focus like this conversation about like cardiovascular disease and heart health because there's multiple plays of GG, and this does involve like this K2 story. And you said in Japan that 45 micrograms a day is what they do for osteoporosis, which obviously you've got here. But in a sense, like you are providing precursors on two different fronts. You got the K1 and then you got the GG to where you're feeding this cycle. So this is I don't know if you've ran clinicals on this, but it looks like a synergy to me on its face because you. And I do this all over the place where it's like you don't just supply the direct substrate of what you're wanting. You also supply the precursors because you're trying to grease the gears of the synthesis of this thing all in one conclusive direction. You're trying to push it all. Everyone's trying to row in the same direction at the same time. And if you can get that going, the synergy that you could create is like a snowballing effect of what you want to happen. The applications here, like you talked about calcification of the arteries and heart disease that's what this is. It's the number one killer of all people. And that's either through obesity, type 2 diabetes, or all these other things that contribute to increased calcification of the arteries. A lot of that has to do with like the different plaques and stuff that develop on the arterial walls. Is there a compromised ability in people who are sedentary, who are obese, who don't have a really good diet to create GG? And is maybe those like gene pathways to make geranyl are like downregulated? They don't make a lot of K2. So you're really making it worse by not having a healthy lifestyle and exercising and also having a terrible diet and all these things kind of converge together to create this atherosclerotic kind of state.
Wow, you asked many questions at one time.
It's all the big picture, man.
I know. I would say that a sedentary person is going to make less MK4 because.
Is it because of the GG though?
Yes. Because when a person do a lot of exercise, it will stimulate the body to make GG. And therefore MK4 like that. So that is, which also is true. If a person exercises a lot, the mitochondria is bigger, it's making a lot more CoQ10. And CoQ10 comes from GG. Remember, just think GG as a building block. You got to have the building block. If you remove the building block, it can't make MK4 and cannot make CoQ10. See, this is new. You got to talk this thing again and again. People know only to supplement CoQ10. I am talking about giving people something anabolic.
Precursors.
A precursor.
Yeah.
I'm using the word not like you think about testosterone. I use the word anabolic as a smaller thing going bigger. And so GG is an anabolic precursor. You need this small thing because GG is 2.5 times the entire GG is in the CoQ10 tail. CoQ10 is like an albatross. That's why people have this, that, and other thing to get CoQ10 to go in like that. But on this one here.
But what's interesting is CoQ10 is essentially aromatic, right?
Very aromatic, very lipid-soluble.
All right, so you don't get anything aromatic inside of a body without having a desaturated fat chain, and that's where these double bonds come in. So as GG will cyclize on itself and form CoQ10, it's using these double bonds to create an aromatic structure. Now this is an odd exception to the rule because this is a mitochondrially specific kind of thing, and mitochondria have like this past evolutionary lineage that like kind of links to bacteria. So in a weird way, like they're the exception to the rule where they can make aromatic things.
I can tell you in a moment, in case I forget, because I want to come back to answer this nutritional panel. If I forget, remember to ask me, where and how does GG make MK4 and CoQ10 in the human body? Remember to ask me that? So on this one here, right? If the vitamin K2, the 45 milligram, borrowed directly from the Japanese. They have been doing this for 25 years. And the Japan is if they have any side effect, they would have known by then. They use that and they use 45 milligram clearly to support bone growth like that. So designed for health. What about the phylloquinone and the GGPs? You use the word as precursor. I will just add yes, it's precursor, an adjective to precursor. The phyloquinone, they call it phytonadione, it's same thing, it's phyloquinone. The phyloquinone is, I call that a catabolic precursor.
Sure.
I call the
It's gotta be
GG,
broken
the
down to build
GG
something else.
and the GG is an anabolic precursor. Why phyloquinone catabolic? Because when it the thing get to the gut cuts it off, so it's catabolized, and then the ring goes in. The ring goes in, and then it's stitched onto a GG. So therefore, you need the ring. Without the ring, you cannot make MK4. You gotta have the ring. The ring is always green, coming from the plant.
Yeah,
You
you're
just
not
cut the
going to make
tail
that
off.
endogenously.
The tail on the GG thing, these are older people. They're probably partly sedentary and they are not muscularly charged. So if you give them a trans GG, and you and I already know it is the building block. So if you give them GG, the GG will go in, then would help make the MK4. And also people have shown if they give to animal just the phyloquinone, the K1, they will see more MK4. You follow? Because
Yes.
it depends on the body's GG. So now you combine all of this synergistically like that. So if anybody want to add something, or there's probably vitamin D, but Design Five sell a lot of separate vitamin D, so they did not want to stick vitamin
So if you were like
D.
making like a bone formula, would you obviously this is kind of expensive, but
Yeah. This is an expensive product.
but either way, like these are really good. These are good bones.
Yeah.
That you would tack on with something like calcium and vitamin D into like one complete synergistic kind of combination.
I would tack on I would tack on vitamin D. I would not tack on mineral. Instead, I would separately have a 2-piece capsule, and then you study bone. You can go out in PubMed, right? It's not just calcium. Calcium is just the dominant. You have all the mineral that is like that, and they have magnesium, boron, blah blah blah.
yeah.
Use a whole string of them and have them in one piece because they are not miscible with oil. Whereas
True.
vitamin
I'll give you that.
K1, K2, GG are
Well, this
all
is a
oil.
soft gel, so it
It's
kind
soft
of has
gel.
to be that way.
So a soft gel. So a combo will be 2 combined, and then if they want to make it slick, like in a blister pack, like that, that would be good. But they specifically zone in on this because these are people who already have osteoporosis like that. But let me tell you about how GG is made and the bioavailability factor. GG, let's say, have molecular weight X. MK4 have molecular weight 2X. And CoQ10 have molecular weight about 4X. So if you talk about absorption, this is very simple. You talk about absorption, then CoQ10 with 4X is the worst to get into the body. You can supplement. Most people don't know it. Even if you make it bioavailable to death with liposome, with like this,
Yeah.
if you use 100 milligram, you'll be lucky 4 milligram absorbed. That means 96% is pooped off. People don't know this. When they say it's 300% more bioavailable, they're comparing with CoQ10 in powder, where 1 milligram absorbed after 100 milligram. So they have 400 milligrams. They see, we got 300% absorption.
That's why you see the dosages all over the place.
Yeah, like that. So that means the big deal, 300 milligram, 300% absorption. That means 4 milligram. So therefore, CoQ10 at the end of the day is not absorbed because it's just a huge molecule like that. So now MK4 is 2x. So therefore, I think it rationally a brilliant idea to give people GG, and GG will absorb very quickly. We have animal studies.
You guys have a
like
study
that.
going on right now about like the synergy between CoQ10 and GG.
Yes.
Looking at the 3 different arms.
Yes,
Okay.
and we're doing an exercise sign one on the muscle, but the one that is ongoing now is done again in your wonderful state. We have people who are taking statin drugs under a cardiologist's care, and statin zap off the GG, like that. It's just on the same pathway. So they have myopathy, muscle problem. And Google this. It's called SAMS, S-A-M-S. Statin associated muscle symptom. It's as simple as it is. If you just put SAM, it will show you, oh my goodness, this is exactly how statin knock off the GG, and GG is unavailable to make muscle, and then therefore people have muscle problems.
So mechanistically, like statins are there to decrease cholesterol levels.
On the same pathway.
So it is in the same pathway.
Yeah.
So I would also kind of think that GG is a building block for all steroid hormones in general. This will really segue us well into where we're going to go with this.
The muscle thing.
Yeah. So, so here's the thing.
We don't have enough hours in a day.
I think we'll do fine.
Yeah.
So
Basically, GG is amazing.
All right, folks, this episode is brought to you by the Future Nutra Foundation, a 501c3 nonprofit organization for the nutraceutical industry. Imagine a world where every dietary supplement you take is safe, effective, and scientifically validated. At the Future Nutra Foundation is not just a dream, it's our mission. We're dedicated to transforming the nutraceutical industry through rigorous scientific research, comprehensive education, and unwavering advocacy for public health and safety. But we can't do it alone. Your support can make a real difference. With your donation, we can drive innovation, ensure regulatory compliance, and provide the public with the reliable information that they need to make informed health choices. Join us in our quest to create a healthier tomorrow. Visit futurenutra.org and make your donation today. Together, we can build a future where trust in dietary supplements is a given, not a question. The Future Nutra Foundation, science, safety, and a healthier tomorrow. Thank you for your support.
And you should take it.
Yes.
Statins, what they do is they inhibit cholesterol synthesis.
Yes.
More or less. And this has impacts on LDL, HDL, the whole gamut, like all total cholesterol, which, you know, if you know anything, like that's not always a good thing to just eliminate the entire thing. What happens when people do get older, and I kind of think that, you know, people have increases in cholesterol in their later years because, you know, they're no longer reproductively active. They go through menopause, andropause. They're no longer creating these sex hormones of testosterone and estrogen. And where does the cholesterol go? It's got nowhere to go. So it's just, let's make more cholesterol because we don't know what else to do. And then these other enzymes that are responsible for turning cholesterol into testosterone and estrogen, they're just, those genes are not expressed as much.
That's right. And then when they make so much cholesterol, there's no place to stack it. So they just littered it on the artery. And then you have plaque.
Well, I mean, this is a weird thing, right? Like once you're no longer contributing to the gene pool, like there's a clock that turns on and all of a sudden things start turning off. And taking statins is a way to improve this biomarker. And in some extreme cases, it does improve health. But like there's a combination of things because the GG is what's used to make cholesterol in certain ways. So like if we're stopping the synthesis of cholesterol, like if the statin is doing this far upstream, then yes, it's having a negative impact on GG, which is trickling into MK4, is trickling into CoQ10, is trickling into all this other stuff. And yes, you do have muscle loss, not only because you're not creating the steroid hormones that your body used to, but you know the cholesterol's got nowhere to go. And then there's this whole thing about GG that I wanted to touch into because maybe this has to do with the same thing, that GG has been shown to improve testosterone numbers in people who have like either hypogonadism or they're just older and they have lower testosterone levels. And it does this through something called the STAR pathway or steroidogenic acute regulatory protein. And it makes me wonder, is there some sort of crosstalk that's going on between the statins stopping the cholesterol synthesis and that STAR pathway? Because that is the rest of the enzymes that are there to turn cholesterol into testosterone and estrogen. And I was talking to Dan about this. I was pulling up KEGG pathways and all kinds of stuff, and I'm like, where's the smoking gun? Because we got to find it somewhere. And you know, they're mainly when it comes from cholesterol, you have 17 beta hydroxysteroid dehydrogenase and 3 beta hydroxysteroid dehydrogenase that are the main things that are converting like progesterone into estrogen and testosterone. And I'm wondering, is this something that's really far upstream? Or is this something that's in between this upstream pathway and the mitochondria? Because that's where all the steroid hormone production gets done. And from what I can tell, that there is concrete evidence that the GG has an effect on something called, it's a cell surface receptor called the adenylate cyclase. And through, I guess, inhibiting that, it causes an increase in cyclic AMP. That increase in cyclic AMP causes cholesterol to come into the mitochondria and get turned into steroid hormones, which is a good thing. And there's more than one ingredient in sports nutrition that does this same trick. And I'm wondering, you know, are there different mechanisms about adenyl cyclase causing the rise in cyclic AMP that are causing the increase in testosterone synthesis? Or is GG having a role that's not at adenyl cyclase, that's further down the pathway that might actually be in the mitochondria itself that's helping cholesterol convert into testosterone and estrogen?
On the cholesterol one, I don't know. On the muscle regeneration thing, it's definitely further downstream. I try to learn this in a different perspective. Very few drugs work as powerfully as statin. I'm giving you a perspective.
In the name, it tells you. It stops things.
Yes. And statin drug is used by 40 to 50 million people, second only to the OTC drug Tylenol. That says a lot to you.
My father takes statins.
Yeah,
Everyone takes statins.
It really lower cholesterol. So from that, this is my take. Because it has been used for 40 years, I try to understand what
it was the best we had at the time.
No, on the side effect to know the mechanism.
Okay.
To know what are the repeatable clinical side effects of statin. Then I flip back to understand the mechanism. The most common repeatable side effect of statin is SAMS, myopathy, statin-associated muscle symptom. So therefore, it has something to do with messing up the muscle one. And the second one would be that it helped to increase some degree of sugar, so they become type 2 diabetic. You can Google. It's from the Jupiter study. Just acronymed. Jupiter study published in New England Journal of Medicine 2009. There's trouble with that, and your cardiologist said, well, what do you want? You want to have a heart attack, or you can live 40 years longer and you develop diabetes? It's related. So therefore, it's the second one. And the third one, when you take a long time taking of statin, you begin to develop some degree of dementia, not Alzheimer's disease. I decided that because this had been documented, I went back to the mechanism to study how the statin worked. Normally, you can't do this kind of rabbit hole chase, but the strangulation of statin on the HMG-CoA reductase is so forceful and so high up that people typically reduce cholesterol synthesis by 50%. Remember, so
that's a lot.
for your perspective, right? If you're talking about testosterone or progesterone, they are nothing. Sorry to tell you this.
Respectively, yeah.
Because cholesterol is the most abundant, highest amount in the human body, and it does so many things. It pales on everything. How do I know this? Because there are 8 to 12 people who get Nobel Prize on cholesterol.
Yeah.
I cannot think of one person who got Nobel Prize on testosterone. So like that, yes,
it's
testosterone can do
Yeah.
testosterone can do magic like this. Therefore, just keep in mind, cholesterol has to be in all cell wall, otherwise our cell don't survive. So it's a big deal.
Yeah,
so
it
therefore
has
we
a lot
have
to do
lots
with-
of cholesterol
Yeah.
in our body. So for then, with all that said, you can have a simple molecule like 40 milligram can zap 50% off. That means that molecule is doing whatever it does, is zapping off good. So what else is it zapping off? So now I go on this. It causes people to have myopathy. So I delve into study why does myopathy happen when 40% mass of a person is muscle like this. I'm not talking about sarcopenia, people exercise, no exercise, this and that. Just why does it happen to people like this? And then the reason is the synthesis of skeletal muscle protein requires GG. That's it. And then they identified that when they zapped off the HMG reductase, they are zapping, the body makes 5 carbon at a time. C5, 10, 15, 20, and then it stops. They just make repeating unit. And C15, this is a good phrase to know. C15 is farnesyl. C15 is the
It's getting a lot of press lately, C15.
C15.
Yeah.
C15 is the last common step and committed step in cholesterol synthesis.
So
it's SAG-way.
GG and farnesyl, they're like cousins in a way.
Cousin, yeah. After farnesyl go this way, SAG-way, it have two farnesyl kissed together. Then there's the first step of steroid synthesis called squalene. Squalene is C30 to C15 farnesyl, C20, and then they cyclize, blah, blah, blah. And many steps later, they become C27, that's cholesterol. And then many steps later, they have all the other hormones. So I'm thinking that I do not see right away, if you take statin drug, that a steroid hormone get inhibited. Because it's 100, 200 step down. So if they get things, that means it affect way down, but it do it for cholesterol. Another 30, 40 steps down are testosterone and progesterone, so it's further down. But they all segue from C15.
Yeah.
Now, GG is C20. C20 is the first uncommitted step to cholesterol synthesis. So therefore, the C20 is not directly related to testosterone synthesis or CoQ10 synthesis. However, when you give people GG, the progesterone and testosterone increase. So the mechanism is not because of the stifling of the mechanism. So when you take GG, the GG is stimulating, you say STAR and the cyclase enzyme to stimulate post-transcriptionally the production of testosterone and progesterone. So it's indirect and post-transcriptional. But the GG for the synthesis of protein, the GG for the synthesis of CoQ10 and the synthesis of MK4 is the direct biochemistry. Mm-hmm. No GG can't be made. So you follow what I mean? So it's not potent. You just have to make it. But the making of the testosterone thing is post-transcriptional, which is why...
If there's anything you're certainly convincing me of is that the statins are not a good thing.
It's not a good... And then now I mentioned about the muscle, right? I also mentioned about the sugar thing. It increased. This is so sweet, man. When I saw it, wow, this is mechanism that is so clear. And this is like this.
Decreased muscle tissue means decreased ability to consume carbohydrates.
That is true. But this one here is mechanistic. They thought it has something to do with insulin because insulin is produced by the pancreas. It's a chaperone and take the sugar and the sugar to the cell to be absorbed. That is it. And the Nobel Prize was given to the Canadian Frederick Banting for this discovery. Beautiful, clear, explicit, and suddenly nobody knows about the pancreas. Pancreas have hero status. Oh, it makes insulin, my goodness, like this. But they found out that statin, it did not cause insulin resistance. It didn't cause that. Let me say that, but it's very beautiful. And then, but the sugar keep increasing. So it's what is the matter? So they found out this. The insulin would take the sugar to the cell. But when you get to the cell, this is a forgotten step. When you get to the cell, the insulin said that, oh, I bring you the sugar. Then the insulin cannot do anything. But when the insulin get to the cell, it stimulates the cell to come up with a protein called GLUT4. This is the guy that opened the door. So the GLUT4 open up and the insulin pass on the glucose to the GLUT4 and it says, see you later, and goes back. And this GLUT4 protein will then take it into the cell. That's it. And you know what happened? GLUT4 synthesis, that protein, requires GG.
Okay.
So you follow that?
Okay.
So therefore,
I'm definitely following you here. Okay.
That was so beautiful. I did not expect that. So you take statin, it messed up the making GLUT4, so the guy cannot open the door for the reception of the...
I was about to say, like, the reception of that glucose from insulin is the most important step in this. And a lot of people regard muscle tissue now as an endocrine organ because of that. And this is how you get to dementia. This is the road to dementia that you were talking about earlier. That if you don't have any GLUT4 translocation, that's just like, and when he says like it takes glucose to the cell, it's really taking it to the muscle cell. That's or liver. But either way, in either case, like that is the reception of the glucose. That is the most important step here. If you have decreased muscle tissue through the use of statins, you're just exacerbating this problem even further. Yeah. If you don't have enough muscle tissue, you're not going to have GLUT4 translocation. And a lot of this is dependent on muscle size, surface area, so the GLUT4 can actually get to the plasma membrane. And the more muscle tissue you have, the more glucose you have the capacity to actually metabolize. And if you've got decreased muscle mass through your statin use, and that could be through several different endocrine factors of decreasing cholesterol, testosterone, etc., but this also having an impact on your lifestyle, because if you're not making any of those hormones, you're not likely to be as active. If you are as active, you're not as likely to recover as well. And if you can't recover, you're not going to build more muscle tissue, and therefore you're going to have a decreased capacity to receive that glucose.
Yes.
And then once again, we're caught in this other really loop, because if GLUT4 requires adrenal then this has a lot of other things. Because if you don't have enough adrenal, like you can even have a blood sugar play on this. Like if there's products out there that are called glucose disposal agents that are completely designed around GLUT4 translocation to the plasma membrane and bringing in more glucose.
This is a perfect one to go in. I'm not.
It's so funny, like how like cardiovascular health and blood sugar health, those things are they go hand in hand, at least
they go hand in
the
hand.
disease context of like cardiovascular disease. But so many people are forgetting that the missing link in all of this is having an abundant amount of muscle tissue to take in that glucose so you can keep metabolizing these things. Otherwise, you have this glucose buildup. Sometimes it'll convert and it'll be turned into fats, where you have like this lipogenesis from glucose stores. And that is another thing that's just adding on to this cardiovascular disease fire. And I'm one of those people where it's like physical activity should be promoted in daily life. We're a very like, as far as like a society is concerned, we're all about all work and no play, but it's the play that actually helps keep us alive. You know, there's no recess at work. You know, that's not a rewarded behavior, but it's something that does keep us healthy. And this is why an active lifestyle is important, so we can maintain these things. Or if you want to be able to shuttle more glucose, GG is another thing to look at. If you want to have better heart health, GG is another thing to look at.
So if you say that people are making product to increase the uptake of people that have GLUT4, then this is it. Remember, I'm not as smart as you think I am. I'm just thinking, I went to read about statin and what side effects. So if I figure out the side effect, then I can go back and understand the mechanism. So that's two. But the last one, right, had to do with MK4. When people take statin for a long time, they begin to have increased dementia. Also, ironically, they begin to have calcification of the artery. They also have to do with MK4. The dementia one is more compelling. Remember I told you that about 25 organs, we make MK4. So in animal study, the only vitamin K in the brain is MK4. Usually you can find some phylloquinone, and if they take fermented food, some MK7.
There's not a lot of blood there. It's not needed.
But they only have MK4. So this is a study done at Tufts University. So they say they measure centenarian. They chose centenarian, and as the MK4 drop in the plasma, the normal cognition, mild cognition, Alzheimer's disease. You with me? MK4. Then they said, well, how are we going to, they found it out on animal. How are we going to do that on human? We can't poke a needle into the brain. So they have a medical school. So they have the centenarian. They believe this, and the children believe this, and they would donate their brain cadaver tissue after they pass. So then she did, this is long study because you have to wait for them to pass and do the study. They did, and then so they have centenarian. They have already scored them. As I told you, the plasma thing, and then here, the brain tissue thing of cadaver tissue, like that. Right after, as the MK4 go down in the brain tissue, the dementia also go up. So now they found the connection that MK4 is inversely connected to the ability to retain memory. And then they found out, wow, how do we now know MK4 is made in the brain? In another study, this is McGill University of Ontario. I read this thing like mad all the time, like that. And she found out, the professor found out, people need to thin their blood. So they take warfarin drug. Otherwise, they have clot, they have stroke, they die, like this. So for long-term warfarin taker, they notice that they begin to lose memory. Follow? And then they found out that they lose memory because the way warfarin work is
You're treating a symptom and not a cause.
They inhibit the recycling of the vitamin K. So when the vitamin K is spent, it's not spent, you can recycle it. But when they add warfarin prevent the recycling. So therefore they cannot regenerate MK4 and lose memory. So now statin inhibit GG, it's inhibiting the P's that make the GG and they're not able to make the MK4 in the brain.
And you know what's funny is like people who are on warfarin, they take blood thinners. They're encouraged not to take MK4.
I have a question.
Is that right?
Yeah, because it'll thin their blood and risk their loss of their chance of dying of blood loss.
I have a question.
Okay.
So is GG in this case taken purely preventative, or if you take it, do you see reversing?
We are now doing animal study on this. I have to do animal study on this. Never been done.
Okay.
I put a young, middle-aged, and old rat. It's obvious where I'm going with this.
Yeah.
I wanted to see in a control, young, medium, old, do I get decrease of MK4 and CoQ10 in tissue? I'm already certain they're going to have decrease
theoretically,
CoQ10.
you're
like that.
right.
Yeah.
But MK4 would decrease, but MK4 directly is made by GG. And now, GG is not measurable in the blood because the phrase to use is well conserved. When you take GG, it directly go to the tissue right away. So it's most bioavailable. So translated for application is you take GG for making MK4
Yeah.
like that,
Yeah,
so
yeah.
like that. So if we do that, we will separately have another animal study. We give them different amount of GG to see how they are taken up in the animal to make MK4 and CoQ10 in the young, middle-aged. And if we don't know the finding, if in the young we find that it did not increase MK4 and CoQ10 that much, which wouldn't surprise me or shock me, then for the very young athletic people, they may not need GG.
Right.
We don't know.
their
It's
their
unknown.
endogenous synthesis may be completely
They're making
fine.
good, but as we get
And
to
they can
middle
take
age,
K1 and
like
be
30
fine.
years old, 40 and older, then we're making less. I'm almost certain about that because it's already been done. As people get from 20, 40, and 60 years old, their CoQ10 drop.
So-
like that. But that for MK4 is not been done. Zero has been done on GG. I need to do that on animal study first. I know Dan would like to do clinical trial. You cannot
Sure.
do clinical trial on this because you cannot do biopsies in all the tissue.
Yeah.
But if I don't have animals, I don't even know anything.
I was going to ask you that. I was like, why don't you just biopsy the muscle and stop checking the plasma?
Biopsy of the muscle is possible, like
So
that.
bringing this to like a supplement, just so I can kind of like understand. I'm connecting these dots, and I'm not a scientist, right? If I could just use a kind of a case scenario. My father's been taking statins for a long time, right? Diabetic, pre-diabetic. But you said that there's degenerative. When you take statins, you get things like memory loss, you get muscle degradation. There's all these things that happen when you take statins. That's basically like this toxic cycle of
It's
degradation.
a slippery slope, but
Right.
it looks good on your blood work.
Yes, it's good on your blood work,
there's
but everything
well-vetted side
else, you
effects.
get sleep apnea.
Yeah, the
there's
doctor gets
all
paid and a high five.
Yeah.
Okay, so what I'm asking is somebody who's diabetic or pre-diabetic or has these issues, if they're going to take GG as a supplement, I know there's not a human study on it. You're saying it's probable that if somebody older in age, 68 plus, probably is taking statins because they have a heart condition or something like that,
Yeah.
they can take GG. For example, I've noticed my father, I know over time you start to lose mental capacity, but since he's been taking statins, I noticed that his memory loss is more prominent. His mental clarity, his ability to recall words, things like that is just a little bit hazier now as he gets older. And I'm wondering if there's a correlation between this.
In animal study, they have shown that, and I can't speak for what to recommend for your father. I'm comparable age. I'm 70 years old.
He just turned 70 a week ago.
Yeah. Oh, so then
Happy
it's
birthday.
very close to my birthday.
Yes.
Happy birthday. And I am taking statin. I've always equivocal about this. I'm thinking of other cholesterol medicine. My cholesterol is high. It's genetics. You know, I don't have heavy weight, this and that. It's
Sure.
just genetically my liver is crazily making a lot
Yeah.
of cholesterol like that. And I'm taking GG to manage my myopathy. I'm not taking GG
that's
to
what I'm-
increase
that's-
my sex
yeah,
drive. I'm
right.
just taking GG, just zapping
Yeah.
off my GG, zapping on my G. I need that so that to make sure I don't have any problem with time as I get older.
Yeah.
On it. So I take GG.
You clearly have mental acuity, right? Like 70 years old, you can hold a 2-hour long conversation.
Oh, you give him enough ghost energy. Keep going.
If I were to do this with my father, about 30 minutes in, he would probably be exhausted and be
You
like,
know, for your father, because
yeah.
you mentioned that he's pre-diabetes and probably diabetes, I know we didn't touch on this, right? If I were to make a single statement about what Annatto Tocotrienol can do, it works on chronic condition. First, we check on lipidemia.
That's what it sounds
and
like.
then,
Yeah, yeah.
on cholesterol and then triglyceride. Lowering triglyceride and lowering cholesterol has got it's not even a nuance. Lowering cholesterol is to prevent arteriosclerosis. But lowering triglyceride is different. Lowering triglyceride are people with metabolic syndrome leading to prediabetes and diabetes. I met only once Professor Gerald Reven. He was an endocrinologist from Stanford, and he was the one that first came up with the word syndrome X before it became metabolic
Yeah.
syndrome. He came up with it. He came up with syndrome X because he cannot figure out when people are pre-diabetic, the sugar is out of kilter, their lipids are out of kilter like this. But when he figured it out, he was giving a talk to receive an award in American Diabetes. I've been a member of American Diabetes Association for 30 over years. I have so many, this kind of thing, I can't even, like you have so many contact with people who are sales, this and that. For me, it's science. My
Yes.
whole life was this.
Yeah.
Endocrinology is big because it's
Yeah.
American Diabetes. And he was getting an award. And then the line was so long, people asking him questions. And I knew I'm a short Asian guy, I can't get his attention. So I sneak around, wait for the guy to leave because he was trying to catch a flight to go back to Palo Alto because he's from Stanford, So I caught him on the side. He said, "Can I ask you a question?" And then he was obviously not happy that I stopped him. Then I said, "Well, you follow this," he said. And I'll tell you what he said to me first, and then I'll put it in simpler language. He said, hypertriglyceridemia always precedes hyperglycemia. And then he took off. That's it. That was his finding for that became metabolic syndrome. That means before people have high sugar, become diabetic, like in the pre-diabetic, they have high triglyceride. So therefore, I always ask people, you have the triglyceride number in your lipid profile when you measure cholesterol. See, if they're very high triglyceride, they probably have pre-diabetic, they probably have fatty liver disease like that. So when I understood that, we decided, I spent 6 years of my life doing this, we decided to be all in. And this is before I was involved in design for health. If I have to, they'll cut me off. This is you're spending too much money, too much time. And then we're going to say, this is not unhealthy people. But I did that. It's finished, published. So we have a 3-month study, 6-month study, and separately a 12-month study, a separate study. It took a long time, And what did I choose to study? I decided I don't want to study people pre-diabetic. I don't want to study. Eventually, we did study those too. I wanted to go after people that have the largest organ, and that is the liver. And I want to go after the 90 million American who have fatty liver disease.
True.
It's
Yep.
clearly metabolic syndrome. We did the 3-month study, 6 months. When we did the 3-month study,
Was this with Delta Gold?
with Delta Gold, just straight Delta Gold, 600 milligram, 300 milligram twice a day. And in the first 3-month study, we studied the liver enzyme, ALT, AST, they drop. Love it. And then the MDA, oxidized fat drop, to be expected because it's a powerful antioxidant, they drop. But the fat in the liver is a challenge by oxidation like mad because it's too much fat in there, you see? So in the
I was also going to ask about that. Like, there's got to be some sort of balance for this oxidation that you do want
that one is
specifically
so
of fats.
obvious like that, And in the 6-month study, I said, I need a little bit more than ALT, AST, like that. I say, I need something that serologically you measure that the health professional want to know. So therefore, we study C-reactive protein, we study, I forgot, a few other enzymes that are marker of inflammation
TAS.
fat. So we study statosis. Statosis is the scientific word of fat in the liver, like that. So we did that, and the fat was egress, like that. Lovely. Then I said, I'm going to do a 12-month study. See, I'm nuts, this is all my own money. 12-month study. See, here, I don't only want the patient and the health professional buy in. I want the liver specialist to buy in on it. So therefore, the health professional is out of the picture. This liver specialist. So then what do I need to do? I need to do CAT scan, or I need to do biopsies, then I said, well, and then the institution does not allow liver biopsies because they don't have frank cirrhosis, they don't have liver cancer, don't have hepatitis, so you can't do this. So therefore I get CAT scan. And in the CAT, and we do some serological markers to study. In the CAT scan, we saw that they have reduced scarring tissue. If the fat is stashed in the hepatocyte too long, then they begin to scarring tissue, and when the liver cell gets scarring tissue, it's beginning to be irreversible. And specialists want to look at that. So now all 3, 6, 12-month study they have. And my R&D director said, Barrie, you notice something else is also dropped that we did not anticipate. Then she told me in the first 3 months, but I didn't pay enough attention because I don't want to say the stupid thing. Then as it turned out, the 3, 6, 12 months, they all have weight loss. And I resisted to say weight loss because people expect it to be 2 weeks. We don't have data on 2 weeks. The first one is 3 months. But then finally, I did it. It was statistically significant. Then we can say it's sustainable weight loss at 3, 6, 12 months, and they typically lose about 12 to 15 pounds. I think the
over
weight
12
loss,
months.
Over 3, 6, and 12 months.
15 per month.
No.
Over 12. Okay.
So once they stay lost. In other words, many weight loss products, the moment you boom, they went back up. It just stays sustained. So all this I can think. The inflammation.
Taking tocotrienol for that long is in fact a lifestyle change.
Yeah, I think that for your dad, give him the tocotrienol to take, and when he goes back to see his regular doctor, they will see that the triglyceride come back into kilter, the cholesterol come back in kilter, his sugar come back in kilter, and in the response of things, the inflammation reduced, his weight also adjusted. So it's more like that than a weight loss product.
Yeah, I get
it.
it.
Doesn't quite work like bourbon.
It works more at the source, like you're saying.
Yeah.
Yeah.
I know this is so fantastic. You guys ask great questions to stimulate me.
I gotta rapid fire a few last questions. We're gonna wrap the show. With the discovery of or all the Nobel Prizes given out about vitamins, cholesterol, and all these things that you are remarkably adjacent to, especially with the story of the parallels of tocopherol, tocotrienol, phylloquinone, and MK4. Why do you think that the world is going to be resistant, at least up until a certain point, to give you a Nobel Prize? What do you feel like you've got left to do?
Oh man,
you're 70, man.
I don't think anybody's going to give me a Nobel Prize, but I sure like I talked to.
You're still publishing,
I do. The last paper I published on the need for using GG because it looked like there's strong evidence that statin inhibit the viral entry of the COVID. This is before we even have the vaccine. And then, so if this is in third world country, they probably use a lot of statin because they can't afford the vaccine, you know, like that. So they don't have issue about anti-vax. They have problem about we can't get the stupid vax. So we gotta get plan B, and plan B would be to do statin. So if that statin use is increased, then you can expect that SAMs would also increase, and then GG would have an implication there. But what I would like to do would be that I want to learn as much as I can that now is not known. GG evolutionarily is made in a human body. What else can GG do in a human body? For example, I'll tell you just
like many things.
It can many things. GG is needed in
GG
is needed in the pancreas, for example. Don't ask me what it does. Another time I can tell you. You mentioned. We were driving up here. He mentioned HMB because you guys are muscle guy. You talk about this all the time. And the HMB is work on HMG-CoA, like that. there is a very rare genetic disease. It's called HIDS. Google, don't ask me this. And then it causes hyperimmune deficiency in an immune disease like that. And this hyperimmunity disease it's zap the making of the HMG-CoA. That had nothing to do with any muscle thing you talk about. And then when they give them GG, it fixes it. Bing, I got an idea when he mentioned to me HMG, so it may be working on the same pathway, but this is severely genetic disease that people cannot make this thing. There's only 300 in the world. I'm working with the doctor now, and that doctor, they published this. Would you believe this? You're listening to it. They published this only 2 weeks ago when she told me, said, Dr. Tan, we're publishing, I cannot talk to you about it until you come on. Who is going to steal that? But yes, wait and publish, it's fine. So it came out. So I talked with the professor in Czech Republic. The other one is in Washington University, St. Louis, Missouri, like that. And she did. They only have it on 3 patients. They only have it on 3 patients because this is all the patient they can get.
Yeah, it's an orphan disease.
And they give them the GG, and they work on the system, and is able to increase the immune system. I said, I love this because for the first time, somebody is telling me that GG increased the immune system. Then this is going to take, I still haven't figured out the muscle thing, the MK4 and the CoQ10, and somebody is telling me that this would increase the IgD, the immune system. I'm loving this. So therefore, GG is systemic in the body. We need GG for everything that is in the body. It's actually very systemic, like that. So if people ask me, should you take GG? As we pass 25, 30 years old, we should take GG for so many reasons. I'm trying to document all of this. So before I physically actually retire or die in my computer, I'm going to figure out everything I can do with GG because I'm given this.
It's another gift.
This is given to me, you know. This is given to me. I discovered this based on Annatto for totally different reason that I'm looking for something else for the eye in the thing like that. And then I found out the Tocotrienols. I almost throw the rest away and only to find out the GG. All this to make this statement. Tocotrienol is doing special things in our body. I think that GG will be the tail that wags the dog.
Second question.
They call that serendipity. Right?
Yes.
Second
question.
What do you think is keeping the FDA from recognizing K2 and tocotrienol as official forms of vitamin E and vitamin K that can be put on a nutrition or supplement facts panel?
I don't know about the vitamin E thing, but the only minimal step that they make is the FDA disallow, although people still do that probably because of ignorance. The FDA disallowed the use of alpha tocopherol where you say 100 IU, 200, 400, or 1,000 IU. The international unit was based on, it's nonsensical. The IU for vitamin E, not vitamin D or K, is based on that. The IU is based on the ability of the mother to bring the fetus to full term.
Wow.
It's a birth vitamin.
Okay.
It's got nothing to do with nothing about antioxidant. It's a birth vitamin like that. So that was it. So that was ridiculous. So now the IU is to be eliminated. So whether it's tocopherol or tocotrienol, they can only put milligram. So there's something about my tocotrienol. Then at least the unit is the same like that.
So this is another technicality thing.
There's a technicality. So they moved that. It's a mini step. On the vitamin.
So it's not even really an FDA thing. It's like an internationally recognition.
Recognition.
Okay.
And the MK4 thing, this is my hope. I'm hoping that we can do some MK4. In the US, osteoporosis is prevented by bisphosphonate drugs.
Which
Forcimex,
are
like
terrible.
And it causes it brings strong bone, yes, but again, degradation of the jawbone. And the acronym is BRONJ. You want to do it, you never go to sleep. There's so many papers. It's called bisphosphonate-related osteonecrosis of the jaw. That means bisphosphonate-related death of the jawbone. That just means that. And then like that. And Why did I take that time to mention that? Two things. The Japanese scientists decided that this is bad. So they decided to use MK4 as an anti-osteoporosis drug, one. And two, you're going to love this. GG again. They want to know why bisphosphonate causes osteonecrosis, which is really weird, And you know who discovered it? Not the doctor, the dentist. Said, Mrs. Jones, what is this? They never seen it. And then sepsis and germs come in because of osteonecrosis. So then they found out that when this happened mostly to women, they found, they all take bisphosphonate drug. That was only discovered in 2009. Then they figure out, from 2009 to today, we got to figure out why take bisphosphonate necrosis of the jaw. You're going to love this. The jawbone, as in all other bone, is osteoblast, build up the bone, osteoclast, to break down the bone. That's it. These are cells that are in the bone. And these cells need GG to make the protein. And bisphosphonate inhibit GG in the jawbone. Therefore, the jawbone die specifically. So now I'm telling you another thing what GG does. They are not related. They are not related to nothing. I think GG just make protein that a cell need to survive. And only I talk about muscle cell because 40% of our body is muscle cell. Otherwise, GG is actually needed in making all kinds of protein in our body. Until we zap it, then we oh my goodness, GG is making. Otherwise, we don't know the GLUT4. Oh my goodness, See, otherwise we don't know why it's for. So, therefore, before we are human beings thinking we're this smart, our body makes GG by the one upstairs to make many things in our body. And as we go old, that decimate. And if we take drugs that nail the GG, then worse things happen. That's it. So if you have friends, think of this.
Relatives, anyone.
I will continue to do GG research in ways. I'm hoping to do more. I'm working with the Czech professor now. We're making the GG pill, and she's going to give to more. This is a particular group of people that they zap certain part of the gene, and so they have this manifestation of extreme fever. Like that, and when she gave it to them, she just said the IgD increased and the episode of fever decreased. So they are trying to find out what the mechanism of GG is. So right now, I'm standing back. I don't even want to know what my GG can do. If you know of something, you go figure it out. You do something. I'm just a dispenser.
Surely this can't be right.
I'm just a dispenser, and then when they figure it out, then. This is a blessing. More happen. So when I say the GG thing that we're doing now, maybe I'm just taking the lowest lying fruit because people have sarcopenia and therefore the muscle thing. I'm taking the brain thing or the making of the MK4.
MK4
because
basically all goes back to that.
And the coke and many people who take GG, I often hear them say, man, I feel increased level of energy. But then, is that because they make MK4? Is that because they make more CoQ10? Is that they make more muscle? It could be all of this. I don't know,
Synergistic.
So I'm running hard, and he's doing the muscle thing, and I'm trying to see the CoQ10 increase, the MK4 thing. And I said, wow. So I'm feeling not physically young, I'm mentally young. I'm going to do more of this.
Yeah,
so
you're reinvigorated.
Give me 2 or 3 years, you got to interview me. Maybe shorter, interview me again when the day that comes out.
It's going to be crazy.
When he gets that prize.
All right, so where do they find you guys?
What do you mean?
I mean, where do they find? I mean, obviously, you can go to AmericanRiverNutrition.com. American-River. Oh, wait, it's American-River.com.
No, just AmericanRiverNutrition.com.
Oh, there's that one too?
I think so.
Yeah, American River Nutrition, no dash, all one word.com.
And if you want to find out more about Tocotrienols, I don't think you can really, unless you go do your own Googling more about Tocotrienols and geraniol. But I want to thank you, Dan. Thank you for coming on. Barrie, Dr. Chan, thank you for being here. This has been an absolute joy.
Yeah, I learned so much. I learned.
Thank you. Thank you.
I feel like I took a course, an entire course on this.
Yeah, in just a short amount of time.
This comes from my father. You know, I come from a extremely poor family in Malaysia. My parents were from China. They escaped the Japanese war, so they came there. And my father had escaped the Japanese occupation. And when he was 35 years old, he died of brain cancer. And people said to my mom, "You're going to be a very sorry woman with 4 young children." And she wasn't, I'm using the word literally and not sarcastic. Why would I say that of my mom? You know, she was an illiterate woman because she had to take her brother away. So she only had 2 years of education in primary 2, grade 2. So I remember, the reason I know is whenever she signed checks, she always hide her hand. I said, "Mom, why do you do that?" Because she was afraid, because the handwriting is like a child. So that tells me like that. So they have instilled in my mind the importance of education, and when I learn it, to pass that is to me the commonwealth, to let people know. And this is a real blessing, you know. I bring food on the table, we are doing well, but to have people get well, that's fantastic. So you guys are doing good in what you're doing, and we're in a wonderful industry, you know. We're not in a drug industry. We're not making bad food for other people.
It's accessible.
Like that. Accessible to other people, you know. And in fact, this bad food is a curse. You know, when you think about the liver toxicity product that we have 20, 30 years ago, they are referring to pesticide, lead, and mercury. Now, people are making their liver sick because of sugar and fat overload from food. And I'm trying to address that with Tocotrienols. I know I can go on and on. These are fantastic. We can do it again. All right. Thank you so much.
And we'll see you guys next time on the Supp Works podcast.